The protective shield of our planet decays and eventually fails. So do our satellites. First, communication satellites in the highest orbits go down. Next, astronauts in low Earth orbit can no longer contact their mission control center. And finally, hazardous, relentless cosmic rays start bombarding everything on Earth, causing havoc and devastation. Are these the terrifying consequences of the planet's magnetic field reversal we're going to face? Right now, as you're watching this video, Earth's north magnetic pole is extremely out of whack. It's so serious that scientists will have to update the global magnetic field model released a mere 4 years ago. Does it all mean that the magnetic pole of our planet will flip soon? Well, be patient, we'll figure it out a bit later. You see, the magnetic pole is moving quite erratically from the Canadian Arctic towards Siberia, and these movements are very unpredictable. But it's normal for the pole to be moving. There are long-term records from London and Paris that prove that the North Magnetic Pole moves randomly around the rotational North Pole over periods of several hundred years. But the most astonishing thing about its movement is that it's speeding up. Around the mid-1990s, the magnetic pole unexpectedly accelerated from a bit over 9 miles to 34 miles a year. And recently, the pole crossed the international dateline, moving toward the eastern hemisphere. The European Space Agency launched extremely accurate magnetic field satellites in 2013. Thanks to them, researchers have superb data they can use not only to make magnetic field maps, but also to update them every 6 to 12 months. That's how they were able to notice that the core field was weakening too. It might be a sign that the planet's magnetic field is about to flip. To understand this process better, we need to figure out how the core field works. Let's say we've got a bar magnet that runs through the center of our planet and has a north and a south pole. This magnet is incredibly strong, representing about 75% of the intensity of our planet's magnetic field at the surface. Our bar magnet is not only moving, but is also getting weaker, by about 7% every century. Admittedly, this bar isn't the perfect representation of the core field. It's more like electric currents generating Earth's magnetic field. Still, this model makes it easier to see what's happening to our planet now. The magnetic field of our planet plays an important role in protecting us from dangerous radiation and geomagnetic activity, which is the product of the interaction between the solar wind and Earth's magnetosphere. Earth's magnetic field also moves. Scientists have been studying and tracking the movement of the magnetic poles for hundreds of years. The historical motions of these poles indicates changes in the global geometry of the magnetic field of our planet, and they may point to the beginning of the field reversal too. That's what the flip between the north and south magnetic poles is sometimes called. You see, if the north magnetic pole moves a bit, it isn't a big deal. But a complete reversal might have a serious impact on the climate of our planet, as well as modern technology. Luckily, such flips don't happen overnight. The entire process stretches over thousands of years. Plus, even though the magnetic pole weakens during a pole reversal, it doesn't disappear completely. So those scary events from the beginning of the video aren't likely to happen to us. The magnetosphere will continue protecting the planet from cosmic rays and charged solar particles, even though there might be some amount of particulate radiation that will make it to Earth's surface. Magnetic fields are generated by moving electric charges. If some material allows these charges to easily move in it, it's called a conductor. Metal is a great conductor, and we often use it to transfer electric currents from one place to another. In this case, the electric current is negative charges called electrons moving through the metal. The current is what generates a magnetic field. Earth has a liquid iron core. In other words, there are layers and layers of conducting material inside our planet. Currents of charges are constantly moving through the core, and the liquid metal is also moving and circulating there, generating the magnetic field. This magnetic field, in turn, produces something resembling a bubble around the planet. It's called the magnetosphere, and it's located above the uppermost part of the atmosphere. This layer shields and deflects high-energy cosmic radiation, which otherwise would be extremely dangerous to people and other forms of life on Earth. The magnetosphere also interacts with the ionosphere, the layer of our planet's atmosphere containing loads of ions and free electrons and capable of reflecting radio waves. The interaction between these two layers and the magnetized solar winds is what scientists call space weather. The solar wind is normally mild, and there's no space weather whatsoever. But sometimes, the sun starts shedding gargantuan magnetized clouds of gas that can accelerate to incredible speeds. They're called coronal mass ejections, or CMEs. They're ejected from the sun over the course of several hours. CMEs usually look like giant twisted ropes and can occur spontaneously. Their frequency varies according to the 11-year-long solar cycle. For example, at a solar minimum, you can observe one ejection per day, and when the sun is in its most active phase, there might be 3 CMAs per day. Coronal mass ejections disrupt the calm flow of the solar wind and cause serious disturbances that can damage stuff both in space near Earth, like satellites, and on the planet's surface. If coronal mass ejections make it to Earth, their interaction with the magnetosphere generates geomagnetic storms. Those can trigger auroras, happening when a stream of energized particles hits the atmosphere and lights up. And then there are also solar flares. They develop more rapidly and with much more energy than coronal mass ejections. Solar flares often occur soon after coronal mass ejections. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. A powerful solar storm can potentially cause a devastating global blackout on Earth. If not for the Earth's magnetosphere, the effects of the sun's activity would be much more devastating. Luckily, the magnetosphere deflects most of the solar material hurtling towards our planet from our star at a speed of over 1 million miles per hour. But even so, during space weather events, there's a lot of hazardous radiation near Earth. It can potentially harm astronauts and spacecraft. Plus, space weather can damage large conducting systems, for example, pipelines and power grids, by overloading currents running inside them. Scientists regularly map and track the overall orientation and shape of our planet's magnetic field. To do it, they use local measurements of the field's orientation and magnitude. That's why they've been able to conclude that the location of the North Magnetic Pole has moved by almost 600 miles since the first measurements were taken in 1831. The magnetic field of our planet reverses on a timescale varying between 100,000 to 1 million years. One can tell how often it happens by looking at volcanic rocks at the bottom of the ocean. They capture the orientation and strength of Earth's magnetic field at the time of their creation. So, dating those rocks gives us a good picture of how our planet's magnetic field has evolved over time. From a geological point of view, field reversals happen quite fast, but they are extremely slow from a human perspective. A complete reversal normally takes a couple of thousand years, but during this time, the orientation of the magnetosphere may shift, exposing more of Earth to cosmic radiation. Such events tend to change the concentration of ozone in the atmosphere. In any case, scientists can't say for sure when the next field reversal will happen, but they keep mapping and tracking the movement of our planet's magnetic north. By the way, the Earth isn't the only planet with a magnetic field. Gas giants, like Jupiter, also have a conducting metallic hydrogen layer that generates their magnetic fields. Jupiter's internal magnetic field prevents the solar wind from interacting directly with the planet's atmosphere. This is Earth, 335 million years ago. I wasn't around then, but there's just one supercontinent, Pangaea. See? Let's watch it shift around and fast forward. Okay, here we go. It just split into two huge pieces. Australia goes this way, North and South America go that way. Africa, Asia, Europe, forming, and there we go. The planet as it is today. Let's keep going. I mean, the continents are always on the move. Over time, some of them will crash into each other. Others will break apart. But that'll take about 100 million years. Better put it on super fast forward. 100 years from now, humans keep spitting carbon dioxide into the atmosphere, and the planet's already warmed up a bunch. The world's ocean levels have risen about 4 feet. The Bahamas? They've totally disappeared. 200 years from now, the Earth's population is about 19 billion people. The climate's gotten even warmer. We're packed in like sardines over here. New medical tech makes it possible to live to 180. But why? Fossil fuel reserves of oil and gas? Long gone. Oh, and the continents have drifted over 16 feet. The Voyager 1 space probe's about to enter an asteroid cloud at the edge of the solar system. It's the most distant man-made object in the universe, I guess. 1,000 years from now, thanks to better quality food, humans are now 7 feet tall on average. Technology solved the pollution and fuel shortage problem. Humanity's doing just fine. Robots do all the work, we just play around all day. Ocean levels have crept up another 10 feet. Islands like the Seychelles, Maldives, Galapagos, and many others have gone underwater. Denmark, the Netherlands, Eastern England, Thailand, and Vietnam are only partially underwater. There's been a huge human migration these last 100 years. Fast forward about 5,000 more years, and it's the year 8113. Humanity's getting ready to open the crypt of civilization. It's a hermetically sealed room in Georgia, in the States. Bad Georgia. It was created in 1940, and it's full of about 800 books on microfilm, recordings of famous people's voices. It's also filled with bits of technology from that time, like a toaster, a radio, and a typewriter. Some awesome people created the crypt of civilization in case humans experienced a major catastrophe in the distant future and had to rebuild civilization from scratch. We'd all go back to using typewriters. 15,000 years from now, our planet has changed its tilt, and the Sahara Desert is now a tropical paradise. Years of rain turn the dry desert into a wild jungle. 30,000 years from now, the Voyager 1 space probe has finally left the asteroid cloud at the edge of our solar system. If it doesn't collide with anything, it'll be flying in the dark, wide-open outer space for a very long time. 50,000 years from now, the climate's changing a lot. The temperature on Earth is beginning to drop, and we are approaching the beginning of a new ice age. The radio signal with a special "Hello, all you aliens out there" message sent into space in 1974 has reached its destination. The message contained the human number system and data about our DNA and our solar system. If there was someone on the other end to receive this signal, we might have a response from them. 100,000 years from now, one of the largest known stars in our galaxy, Canis Majoris, explodes with enormous force. The explosion of this supernova can be seen from Earth, even during the day, and the nights are much brighter because of the new strong glow in the night sky. What's new on Earth? Supervolcanoes start erupting all over. These volcanoes spew colossal amounts of lava and ash everywhere. Thick black clouds cover most of the sky. This prevents the sun's rays from reaching the ground, and the temperature on our planet drops even lower. Humans mostly live underground anyway, so it's no big deal. Because the stars are gradually moving in different directions, the usual constellations are starting to change shape. Soon, we'll need to come up with totally new constellation names. 250 years from now. Oh, a new island's on the map. Back in 2021, it was just an underwater volcano somewhere in the Pacific. After thousands of years of spouting out lava, it finally reached the ocean surface and busted out in the cool, fresh air. Not much growing on it yet. Niagara Falls has long since disappeared, and Lake Erie and Lake Ontario have teamed up to form one huge super lake. 300,000 years from now, the triple star system WR-104 is about to explode. It's spinning crazy fast, and there's a chance that radiation from the explosion could eventually reach Earth. That would do a lot of damage to all life on our planet. Voyager 1 reaches the brightest star in the night sky, Sirius. Not a very funny star at all, it's really Sirius. It's 8.6 light-years from Earth. 500,000 years from now, scientists are pretty sure that a huge meteorite could fall to Earth any day now. It might be even the size of 8 football fields. The impact of such a massive meteorite would cause an explosion so powerful that its sound would be heard on every continent. That would be followed by super strong earthquakes and tsunamis higher than the Brightside Empire municipal building tower thingy. Okay, I just made that up, but who knows what we'll be building in the future. 1 million years from now, the rogue star Gliese 710 comes very close to our solar system. We're surrounded by a huge shield of asteroids called the Oort cloud, and the rogue star is beginning to affect the asteroids hanging out in there. It grabs them, spins them around, and throws them toward the center of our solar system. Comets start to fall on our planet all the time, big ones, causing more tsunamis and earthquakes. 10 million years from now, the Red Sea is gradually expanding into the East African Rift. Africa is now divided in two by a new oceanic gulf. The human DNA molecule has completely decomposed. But it's no big deal. We've become totally digital, without any pesky aging problems. The really cool thing is that other animals have evolved a lot and changed ridiculously. Thanks to a simple interface, we're actually able to talk to dolphins, chimps, dogs, and cats. Turns out cats aren't grumpy, they're just busy contemplating life. 25 million years from now. The San Andreas Fault has been crazy recently and has caused the Gulf of California to flood the Central Valley. There's a new sea on the west coast of North America. 50 million years from now, Africa just collided with Eurasia. The Mediterranean Sea is totally gone. There's a new tallest mountain in the world. Its name? Mount Everest, of course. Australia is continuing its journey north. It already collided with Southeast Asia a few million years ago. The few human colonies still left on Mars need to do some serious packing. Phobos, one of Mars' moons, is beginning to orbit at a lower and lower altitude. That's not good. It's about 14 miles wide, so that's going to be unpleasant. 60 million years from now, the Canadian Rocky Mountains have completely eroded. It's just one gigantic flat plain. 80 million years from now, all that remains of Hawaii is one island. All the others have long since gone underwater. But just next door, a whole new chain of Hawaiian islands has emerged. Finally, 100 million years from now, we made it! The Atlantic's shrinking down to nothing. The Americas are almost rubbing up against Africa. Africa's already merged with Eurasia. We've got ourselves a supercontinent again. Hello, Pangaea Proxima. All traces of human life are gone or buried deep underground. The movement of the continents has destroyed tunnels, roads, buildings, bridges. Animals and plants now reign supreme on Earth. So, where are all the humans? Well, remember we made the jump to digital about 90 million years ago? Things are still going strong. There are trillions of human minds living on a huge hard drive on a spaceship orbiting Earth. The super low space temperature is good for keeping the drive nice and cool. We have millions of different societies, languages, and cultures, just like we had 100 million years ago. The only difference? We're all little ones and zeros in a huge digital universe that we created. And yes, there's still football. It began as slight jolts from under the ground. Nobody really paid attention to them, especially in seismically active regions. People thought these were just minor earthquakes. They talked about them in the news, but only few actually cared. My parents, I was only 12 back then, were among those who did, but let's save it for later. In just a year, the jolts became much stronger and more frequent. In some areas, they turned into full-fledged earthquakes, doing a lot of damage to cities and villages. Worse still, previously dormant volcanoes began waking up. All over the world, people started raising alarm. Scientists talked a lot about climate change and impact of humankind, but it was obvious nobody really had any definitive answers. It didn't get any better either. As months went by, earthquakes and volcano eruptions gradually grew in power and frequency. At first, only one major natural disaster per month was reported. But in 2 more years, there were at least 4 of them occurring within the same period in every corner of the world. Even the normally calm regions suffered from quakes and resulting tsunamis. People tried to adapt, but it was all unfolding too fast for us to react adequately. All we had left to do was to learn to be always ready to move out from our homes and run. We stopped building big and sturdy apartment buildings, opting for lightweight 3D printed houses. They were easily destroyed but easily built too, which was a huge advantage. Items of luxury were rapidly losing their value, while on the other hand, mobile electronics and survival tools grew in price. People began really appreciating what they had and each other. Neighbors were helping one another, and whole towns unified their efforts to build strong communities and prepare for the worst together. And the worst came sooner than we expected. One day, the whole planet was shaken in one titanic earthquake. We thought it was the end for us all, because the ground went on shaking for hours and didn't cease until the next day. And then came reports from the Atlantic coast. The ocean receded, leaving vast swaths of naked sand and corals. Research teams on helicopters went to learn what caused this cataclysm and found the unthinkable. There was an enormous whirlpool in the middle of the Atlantic, hundreds of times bigger than the largest sinkhole in the world. The water from the ocean was gushing down the gigantic drain, as if someone pulled the plug on the bottom. In a sense, that was exactly what happened. Tectonic plates beneath the Atlantic came apart, forming a huge gap in the bottom. Boiling magma poured out, but was extinguished by the overwhelming mass of water, which then rushed down into the abyss. It went away so quickly that the overall water level fell in a matter of hours. The event was dubbed the Great Atlantic Rift, but it was still only the beginning. With the rising frequency of earthquakes and eruptions, wind patterns around the world changed, resulting in massive hurricanes. It seemed the whole planet was against its inhabitants. But like I said earlier, my parents were the ones who cared, and they had to know the reason. They were geologists at the International Space Agency, which continued its work even through all the cataclysms. And it was them who came to the distressing conclusion. For some unknown reason, the Earth had started to grow in size. It would explain everything. The ever more frequent earthquakes were caused by tectonic plates come into motion. The flowing magma was pushed from the mantle up towards the crust and burst onto the surface in places suited exactly for that – volcanoes. And that meant there would be other events like the Great Atlantic Rift, only even more catastrophic. After another year, we moved to live in the agency, along with the families of other employees and research workers. The buildings were made to withstand almost anything, so we were protected from the horrors of the outside. We took in as many people as we could, but of course, it wasn't nearly enough. Millions more were left to their own devices, and we could only hope that everyone was safe. By that time, as scientists estimated, the planet had already grown 1.5 times its original size, and by the looks of it, the rate at which it ballooned was growing. In another year of our bunkered life, we witnessed it grow twice again. Rifts even bigger than the one in the Atlantic popped up in different parts of the world, causing widespread chaos. Everyone went to live underground where it was relatively safe. Communications between continents were all but lost, and all we learned about the situation above was from daring expeditions by scientists. The planet was ravaged by quakes, volcanic eruptions, tsunamis, and hurricanes, happening almost daily now. Life on the surface was virtually impossible. It was then that the joint team of researchers and engineers suddenly came out with the solution they'd been working on for the last 5 years. They called it the Ark. It turned out several teams agreed to build huge spaceships to evacuate humankind, along with the surviving animal, fish, and insect species in case the Earth comes apart. And the time they'd feared finally came. Everyone in the agency's buildings, including me and my parents, were escorted to an enormous hall where one of the arks was kept. All other people from the continent who managed to come were also there. We were given personal IDs and then allowed to board. Each person was allocated a separate capsule that was to keep us hibernating for the whole time of space travel. We were told we were the colonists, the pioneers in space settlement. We were going to Mars. And that's how I ended up here, where I'm writing all this. We successfully boarded the Ark and were put to sleep in our capsules. When I woke up, we were already landing. I won't bore you with the details of terraforming and settling in our new home. At first, we all wore special suits equipped with oxygen tanks. But soon enough, we built a dome with artificial atmosphere and started making the territory suitable for living, both for us and for the animals we brought. Since then, 10 years have passed already. We're feeling almost at home on the red planet, which isn't really red anymore. There are lush forests and big cities sprawling all around. Mars is inactive, so there are no earthquakes or hurricanes here. Life is pretty peaceful, although it's as busy as can be with all the work that still has to be done. But all this time, we've all been anxiously watching our home planet grow in size. At first, it was barely visible in the night sky, but as months passed, it became more and more apparent until one day it could be viewed in some detail with an unaided eye. Today, it's the size of the moon in our skies and visible even in the light of day. The sun is much smaller from here than it was seen from Earth, so basically, our home planet is now larger than its star. Through telescopes, we can see its surface covered in scars and fissures dozens of times bigger than the Grand Canyon. There are no more seas and oceans, and continents drifted far apart. The once green and blue and welcoming world is now a barren wasteland, boiling with fire and brimstone. The sun isn't helping it either. When the planet was small, the star bathed it in its light and warmth, giving it life and energy. Now, when Earth is 100 times larger, the sun is scorching its surface and burning off the remnants of its atmosphere. But even that's not all. With the size, the gravity has grown too. Being so big and massive, Earth has collided with the Moon, virtually eating it up. Venus, which was similar to the previous Earth, started to be tugged toward the suddenly grown planet and was soon to run into it as well. And Earth itself is slowly gravitating toward the Sun. Scientists say that one day it would first consume both Venus and Mercury and then get burned completely in the Sun's heat. Wow. All I can hope now is to never see it with my own eyes.
Earth's magnetic field hides a fascinating story. It turns out that it's getting weaker day by day. In fact, it's been doing so for the last 3,000 years. And if this trend continues, we could be in for some trouble within a millennium. What's the big deal? Well, picture this. Magnetic north becomes south, and vice versa. Pretty wild, right? When this happens, our planet's protective magnetic shield might weaken, allowing more cosmic rays to hit us. These high-energy particles from the universe can cause electronic malfunctions in our satellites and produce elements that could be harmful to us. The last time a polarity reversal occurred was between 772,000 and 774,000 years ago. Thankfully, humanity has some pretty smart people on the case who are investigating the history of Earth's magnetic field. They take cores of sediments from the seafloor and study the magnetization of fossils to figure out when these reversals occurred in the past and when they might happen again. Another group of researchers is studying the South Atlantic Anomaly, SAA, a vast region of Earth's magnetic field that is about 3 times weaker than the field at the poles. Using data from multiple satellites, they are trying to figure out what's causing the SAA and how it might change in the future. This could give us a glimpse into how a weakened magnetic field can affect our satellites and our planet. Sure, our generation won't be here to witness these changes, but it does make you wonder what that planet might look like upside down. Magnetically, that is. NASA's astronomers have also announced that in 4 billion years, the Milky Way galaxy is going to get a major glow-up. After a cosmic collision that will shake things up. I'm not talking about a small fender bender here, I'm talking about a titanic collision with our neighboring Andromeda galaxy. Humanity will have to hold on to its space helmet for this one, because the sun might get flung into a new region of the galaxy. However, our Earth and solar system probably won't be seriously affected. Sounds difficult to believe, so how come? NASA's Hubble Space Telescope did some hardcore measurements of Andromeda's motion. Although the galaxies will plow into each other, the stars inside each galaxy are so far apart that they won't collide with other stars during the encounter. However, the stars will be thrown into different orbits around their new galactic centers. According to simulations, our solar system will probably be tossed much farther from the galactic core than it is today. Set your telescopes aside. You don't need to start counting down the years. This event is likely scheduled in about 4 billion years, so chances for us to witness it are 0. Saturn is losing its rings. Thankfully, we won't be here to witness this sad event either. Apparently, the rings are being pulled into Saturn as a dusty rain of ice particles, all under the influence of Saturn's magnetic field. According to NASA's research, the ring rain is draining an amount of water products that could fill an Olympic-sized swimming pool from Saturn's rings every half an hour. The entire ring system will likely be gone in 300 million years. Scientists believe we should consider ourselves lucky to witness Saturn's ring system at all, as it seems to be in the middle of its lifetime. But if you think about it that way, that rings around planets are all temporary, there's a chance we've just missed out on the giant ring system of Jupiter, or those of Uranus and Neptune. These planets have only thin ringlets around them these days. Scientists have long debated whether Saturn was formed together with its rings, or if the planet acquired them later in life. The new research favors the second scenario, indicating that they are unlikely to be older than 100 million years, while Saturn itself is around 4.5 billion years old. What caused the rings to appear in the first place? Well, there are a few theories. One of them suggests the rings could have formed when small, icy moons in orbit around Saturn collided. Perhaps their own orbits were messed up by a gravitational tug from a passing asteroid or comet. Who knows what humans might end up looking like in the future? It's unlikely we'll see any major changes in our lifetime. But let's take a journey to the future and ponder what we might evolve into. Will we become cyborgs with all sorts of cool machine implants? Or maybe we'll become a hybrid species of biological and artificial beings. To understand our future evolution, we gotta take a peek at our past. 1 million years ago, Homo sapiens didn't even exist. There were a few other similar species though, like the Neanderthal. Fast forward to today, and humans have become taller and sturdier. Maybe in the future we'll become smaller to conserve energy, as it's predicted that our planet will get more crowded. Speaking of crowded planets, living in these new conditions means we have to adapt, and fast. We're constantly interacting with lots of people, and remembering names is becoming a crucial skill. Luckily, technology might help us out with brain implants that will improve our memory. In the future, we might also have more noticeable technologies as part of our appearance. Imagine having an artificial eye with a camera that can read different frequencies of light. While predicting 1 million years into the future is pure speculation, we can use bioinformatics to make some predictions about the immediate future. Demographic trends suggest that urban areas will become more genetically diverse, while rural areas will become less diverse. And what about space? If we end up colonizing Mars, our bodies could change due to lower gravity. Maybe we'll have longer arms and legs, or even insulating body hair like our Neanderthal cousins. In the future, our moon is also going to witness some dramatic changes. We'll miss these ones too. In about 5 billion years, things are going to get really interesting in this corner of the universe. For now, the sun is chilling in its main sequence phase, just burning hydrogen like nobody's business. In the future, during the red giant phase, the sun is gonna puff up like a balloon until its atmosphere reaches out and engulfs our beloved Earth and Moon. Our natural satellite, which is already moving away from Earth, is gonna get warped around the sun's influence. Its orbit will get all wonky, and it'll end up closer to Earth during the new moon phase than during the full moon. And that's not even the worst part. If left alone, the moon would keep on moving away from Earth until it'll need almost 50 days to orbit us. As the sun continues with its own journey, its atmosphere will drag on the moon and cause its orbit to decay. Eventually, the moon will get torn apart into a stunning ring of debris circling Earth. We're talking about all its mountains, craters, and even the footprints and flags we left there, all scattered throughout the debris field. There's a chance the sun will shed enough mass to spare Earth and the moon from total annihilation. Or if we're really lucky, the sun will lose 20% of its mass and we'll be safe and sound. It's all just theory right now. We haven't seen a red giant star during this phase. The universe itself might go completely dark one day too. Scientists can't predict it with absolute certainty, but they can make some educated guesses. Right now, our universe is 13.77 billion years old, and it's still churning out new stars left and right. It's said that eventually, after about 1 trillion years, the last star will be born. That final star will be a little guy, a red dwarf, just a fraction the size of our sun. These stars are champs at living long lives, slowly sipping on hydrogen to keep their fusion reactions going. But even they can't last forever. Fast forward about 100 trillion years, and the last light will go out. The universe will be dark and lonely, but thankfully, we won't be here to watch it all fade away.
Tell me the truth. You probably think that Earth's magnetic field is caused by a big ball of solid iron in the middle of the planet, right? Yep, I mean the inner core. But the problem here is that in the inner core, the temperatures are so high that the very magnetism of iron itself is changed. Once such a temperature, which is called the Curie point, is reached, atoms aren't able to align to a magnetic point anymore. So, in reality, Earth's magnetic field is created by the swirling outer core, and magnetism there is more than 50 times greater than it is on the surface. The liquid iron in the outer core conducts electricity perfectly, which helps it create electrical currents driving the magnetic field. Without it, our planet wouldn't be able to hold onto its atmosphere. As a result, we'd lose our main protection from extremely dangerous space radiation. But it wasn't the outer core that surprised us not so long ago. Scientists say Earth's inner core has likely stopped rotating relative to the mantle and the surface of the planet. Even more exciting, it could even go into reverse. But let's look into the details. Earth is formed of the crust, mantle, and outer and inner cores. The solid inner core is about 3,200 miles below the crust. It's separated from the semi-solid mantle by the liquid outer core. Yep, the one thanks to which we have the magnetic field. And since this outer core is liquid, it allows the inner core to rotate at a speed different from the speed of our planet's rotation. Earth's core has a radius of 2,200 miles and is almost as large as Mars. It mostly consists of iron and nickel and makes up around 1/3 of Earth's mass. The spin of the inner core is powered by the outer core. It turns out that the slowing of the core started in 2009. Since that time, seismic records, which had previously been changing continuously, have shown little difference. And it makes scientists conclude that the inner core's rotation has paused. But we're nowhere near the scenario of a disaster movie. Apparently, the inner core taking a temporary break is part of its 70-year-long cycle. During this cycle, the core switches directions every 35 years or so. This might influence Earth's magnetic field and the length of the day, but some researchers are skeptical about it. And some scientists even go as far to say that the inner core isn't moving at all. Okay, but what would happen if Earth's core indeed stopped rotating? Well, if it was the solid inner core, the answer would be nothing dramatic. Even if it didn't just reverse the direction of its movement, like it's doing at the moment, but stopped altogether, it would just impact the speed of Earth's rotation. It'd slow down, making our days longer. Plus, with time, it could probably degrade our planet's magnetic field, and it would be bad news. But not as bad as they would be if the outer core stopped spinning. As you already know, without this layer's rotation, Earth would have to kiss its magnetic field goodbye, and that's how the downfall of the planet would begin. Things would start getting shaky. The tectonic plates would begin to slam into each other. You know, like when you're going by bus and the driver suddenly hits the brakes and you end up flying into other unfortunate passengers? Yeah, like that. The sudden collision of tectonic plates would trigger destructive earthquakes along the plate boundaries all over the world. They would wipe buildings, bridges, and roads off the face of the Earth. Water systems, electricity, and phone lines would also be destroyed. But the worst would be yet to come. Without the protective magnetic field, cosmic radiation would start hitting the surface of our planet. These high-energy particles coming from the sun would come in contact with oxygen and nitrogen in our atmosphere, effectively destroying our ozone layer. This would allow even more cosmic rays to reach the surface of Earth. The radiation would damage all kinds of electronic devices and disable power grids. And the consequences would be disastrous, not only for people, but for all forms of life on Earth. The stationary core would make navigating the planet more difficult. People would have to start using trail maps again, since compasses would become useless. It would also make it harder, if not impossible, for migratory animals to find their way. Birds would keep losing directions, and turtles would fail to find beaches where they used to lay eggs. Luckily, we don't need to worry about this kind of apocalyptic scenario. The planet's outer core is very unlikely to stop anytime soon, if ever. Now, do you want to find out something cool? Then listen to this. Our planet's inner core has a core of its own. Scientists have made this discovery just recently. They've learned that this core in the core could have developed around 500 million years ago as a result of some dramatic geological changes. What about other planets? Do they have the same cores as Earth? Let's look at Mars, one of our planet's closest neighbors. Its heart is the size of the Moon. It's also almost twice as dense. Scientists made this conclusion after they got some data about the first observed Marsquake and meteorite impact. Both these events were captured by NASA's InSight lander, which had been monitoring seismic activity on the Red Planet for 4 years. The researchers also estimated that Mars's core is probably made mostly of a liquid iron alloy with a smattering of hydrogen, oxygen, and carbon. One day, Mars probably had a nice rotating core that supported the planet's magnetic field. There could be warm oceans swarming with life. But then, something must have happened, and on one terrible day, the red planet's core froze in place. It could have led to the weakening of Mars's once strong magnetic field. Its atmosphere was taken away by powerful solar winds, hitting the planet at a speed of several hundred miles per hour. And the red planet turned into a lifeless, dry desert. Now, what about gas giants? Let's take the largest and the most massive planet in the solar system, Jupiter. It's twice as massive as all other planets of the solar system combined. Almost 1,300 Earths could fit into this huge thing. Jupiter also has the shortest day in the solar system. It lasts a mere 10 Earth hours. At the same time, the gas giant needs 12 Earth years to complete an orbit around the Sun. Jupiter most likely appeared at the same time when the rest of our solar system formed, about 4.5 billion years ago. Probably the coolest thing about this gas giant is that it has the same ingredients as a star. But unfortunately, or should I say luckily, it hasn't grown massive enough to ignite. Scientists don't know for sure what Jupiter's core looks like. According to most theories, the gas giant has a dense core made up of heavy elements. During its formation, it was probably a collection of debris, icy material, and other small objects like comets and asteroids zipping around. Thanks to their mutual gravity, these bits of matter clumped together, forming larger chunks which later turned into Jupiter's core. At one point, it became massive enough to start attracting hydrogen and helium. More and more gases accumulated around the core until what we today know as Jupiter appeared. There's also a possibility that Jupiter doesn't have a core at all, or it might have existed once, but since then, it's eroded away. Hopefully, we'll find out the answers to these questions soon enough, since Juno, NASA's space probe, is orbiting Jupiter, collecting data about its gravitational and magnetic fields. So, what about the gas giant's magnetic field, you may ask? Does it even exist? Oh, don't worry. Jupiter is surrounded by a ginormous magnetic field called the Magnetosphere.
You're inside a small spaceship. You're flying higher and higher, then leave the atmosphere of our planet. Hundreds of thousands of satellites with glowing advertising banners appear in front of you. One of them says, "Happy New Year, 5699. This year you have an anniversary. You will be 5,000 years old. You press a button on the touch panel and activate the ad block. Now you can't see any holographic banners through the glass. You're going to make a jump through space. A black tunnel called a wormhole appears in front of the ship. You fly inside and the hole disappears. The ship has teleported to the Andromeda Galaxy. You discovered an exoplanet here recently, similar to Earth. It's also blue, has a lot of water, but only one huge continent. The planet is hidden in dense interstellar clouds, and you hope that other people won't find it soon. But as soon as it's entered into the intergalactic register, you'll definitely buy this planet. You call it second home. Now you're flying into the atmosphere, going through the clouds, and landing on a small green hill. At the foot of it, you see several small houses made of clay and stone and thatched roofs. Near the houses, locals are working in simple clothes. They're plowing the ground, and cows are eating the grass nearby. You have turned on your stealth mode, so the locals can't see you. They aren't real people. You created them using cloning technology. The conditions on this planet are now the same as they were on real Earth in the year 699, the year when everything changed for you. You remember swimming in the lake at night and looking at the stars. One star moved from its place and began to approach. A huge flash of light and something heavy fell into the water. You lost consciousness and woke up in the morning on the shore. Only 1,000 years later, you realized it was a meteorite. The day after the star fell, you noticed that any damage on your body instantly disappeared. After a couple of decades, you realized that you get older slower than the rest of the people in your village. After another 50 years, you understood that you didn't age at all. Knights, Vikings, the Dark Middle Ages, the geniuses of the Renaissance. You see it all with your own eyes. You become an emperor of a huge empire, and then you get bored and decide to live in the slums to feel all the shades of this life. You think that some magic gave you immortality, but then you realize that any magic or sorcery is really science. You communicate with the greatest minds on the planet, make friends with incredibly bright people and really bad ones to understand the nature of humans. Around the 15th century, you've got all the knowledge and read all the books that people could give you by this time. You begin to explore the world yourself. You discover the process of photosynthesis in plants, grasp the fundamental laws of physics, conduct amazing chemical experiments, and find out that you live on a tiny planet in an infinitely vast universe. Biology, chemistry, physics, astronomy, you learn and explore everything. The results of your scientific research in these subjects are ahead of humanity by 100 years. While the whole world is riding horses, you're already building a car with a steam engine. To hide your identity from people, you constantly change your name and place of residence. Over 1,000 years, you have learned all the languages of the world, and even those that no longer exist. You study all the psychologically known personality types. Your social and emotional intelligence is so developed that you can create a person's portrait after 1 minute of talking to them. You look into their eyes and understand what they want, are afraid of, or are ashamed of. You spend several years in continuous meditation to calm your mind and gain wisdom. You lead the life of a hermit and watch humanity slowly develop. But then, the 20th century comes, and the life of the entire planet changes dramatically. The Industrial Revolution, the first cars and trains, cinema, radio, and television. In these 100 years, people are changing more than they have in the previous 1,500 years. Now, it's hard for you to keep up with the world. New inventions appear every day and every hour. The knowledge and experience of previous years help you become one of the most influential people on the planet. World leaders listen to your opinion. Thanks to your developed communication skills, you can negotiate with any person. You go through expensive and high-quality plastic surgery operations so that no one will recognize you. You keep moving and getting a new ID every 20 years. You have a lot of money, as well as gold and other valuable metals that you've collected for centuries. You build houses and shelters in the most beautiful places on the planet. You finance the development of new technologies. Sometime in the 1950s, you predict that in the next century, there will be a unique network that will allow you to store all the knowledge of the world in a small device. With the help of this network, all people will be able to communicate with each other from different points of the Earth. You're surprised that the Internet appears much earlier. Developers create virtual reality worlds with photorealistic graphics. Artificial intelligence is smart enough to rule a small country. Genetic engineering allows us to clone people and mix our bodies with robots. The first cyborgs appear. With each passing century, there's less and less space on the planet. You get tired of people and consuming new technologies, and you spend more and more time in your home on the top of Mount Everest. Humanity is taking over Mars and the Moon. Soon, these places aren't enough for people too. In the fourth millennium, scientists create a quantum engine to travel through space. You're among the first people to try this technology and make the jump to another group of planets orbiting a star similar to our solar system. Your ship breaks down and you can't go back. You're left to live alone on a new planet. Your body adapts to the conditions on it, so you don't need oxygen reserves. Then, you learn to breathe without oxygen at all. The cells of your body receive what they need for normal functioning from the surrounding gases. Your skin is getting rougher because of the dusty atmosphere of the planet. And with the increased gravity, you develop incredible strength. You'd become a super person with such a body on Earth. You manage to send a signal into space, and you hope that humanity will catch it. You've been living alone for over 500 years without books, the internet, or any communication. You spend most of the time exploring a lifeless desert world. Using parts and tools of the ship, you create a vegetable garden. You also have a lot of water reserves. During all this time, you realize that you miss the old world and your life before the meteorite fell. Some spaceship picks up your signal and comes for you. You return to your homeworld. Travel between solar systems is now as easily available as travel by subway or bus. You decide to find a planet as similar to Earth as possible to recreate human life there. Using the power of modern telescopes and your knowledge of astronomy, you discover what you've been looking for in the Andromeda Galaxy Nebula. You arrive at the second home and live a human life there. For hundreds of years, you observe people and mentally go back to your past. You protect those people from external threats, like asteroids, but don't interfere in their lives. From time to time, you fly to Earth and other planets for business. Life on the second home is becoming very similar to life on Earth. There are more and more people and cultures. Technologies are emerging. You have completed your goal, and now you want to discover other worlds. You spend the next 5,000 years studying the ever-expanding universe.
Imagine a world of seething hot metal where iron and nickel dance in a fiery inferno. This is the inner core, the heart of our planet. But what if this very heart was changing? The latest research suggests that the Earth's inner core may be slowing down and even reversing its rotation. Is this a sign of the end of times? Will the Earth come crashing down on itself? Let's find out. Imagine you have a giant onion, and every layer represents a different layer of the Earth. The center of this onion, the part you can never reach, represents Earth's core. It's like a mysterious land that no one has ever set foot on, yet scientists have been trying to uncover its secrets for centuries. Imagine diving deep into the center of the Earth, beyond the crust, the mantle, and finally 1,800 miles below the surface where you'd reach the inner core. It's a ball of seething hot metal made up of solid iron and nickel, and it's so hot it glows a brilliant white. It's also surrounded by a liquid outer core. This mysterious place is unlike anything else on our planet. And get this, it's spinning on its own axis. The inner core is like a fire tornado that's constantly swirling, generating heat and energy from the inside out. But why is it so important to study this little piece of the Earth? Well, it's responsible for creating our magnetic field. This magnetic field is important to study because it protects us from harmful radiation from the sun. It's created by the movement of molten metal in the Earth's outer core and the spinning of the Earth. These movements generate electrical currents, which then create the magnetic field. It's like a shield that protects us and helps us keep our planet healthy and safe. But there's still so much we don't know about the inner core. For example, how did it form? Scientists believe it started to solidify about 1 billion years ago. But why did this happen? What was the trigger? Or, for example, what about the inner core's crystal structure? It's thought to be a type of iron called hexagonal close-packed iron, but we still don't know if it's actually the case. In other words, we may have many theories, but unfortunately, there's no way to confirm them, at least for now. So how do scientists study the inner core if no one can go there? They use seismology. Seismology is like a sonic scanner for the Earth. You send sound waves through the Earth and measure how they bounce back to see what's inside. That's basically how we discovered the inner core way back in the 1930s. Imagine you're listening to the sound waves with your special seismology machine. Suddenly, you hear a strange sound like a ping. It's different from the other sounds you've been hearing, and you can't explain why. You keep listening and you hear the ping again and again. You start to realize that this ping is happening every time the sound wave hits the Earth's center. You study the data more and more, and finally, you figure it out. The Earth has a solid core. This discovery was a big breakthrough and helped us better understand what's inside our planet and how it works. Right now, scientists also use something like this to study what's inside our planet. When earthquakes occur, waves travel through the Earth and bounce off different layers, including the inner core. By studying these waves, scientists can learn about the inner core's properties, such as its density and temperature. They're basically solving a mystery by piecing together tiny clues. And every new discovery brings us one step closer to understanding it. The inner core is a unique and fascinating part of our planet. It's a place where the laws of physics work in different ways than they do on the surface. And it's a place where scientists are still trying to unravel its many mysteries. And here's one of them. For some reason, the heart of our planet is about to stop spinning. A new study about this was published in Nature Geoscience. It was made by the researchers at Peking University in China. it has revealed a huge twist. The scientists found that the inner core spin rate has slowed down significantly. It's something that no one expected, but according to the results of their study, the slowing down began all the way back in 2009. And that's not all. Their results also suggest that the inner core may be reversing its rotation. That's right. This hot ball of iron and nickel that has been spinning around for millions of years may be slowing down and changing direction. It's like when a spinning top starts to slow down, except this is happening in the center of our planet. Scientists have been puzzled over the discovery for quite some time now. So, what does it all mean? And why is this happening? Well, it turns out that there might be a larger pattern at play. The scientists believe that this change in their inner core's rotation may be due to the influence of Earth's mantle and the magnetic field of Earth's outer core. The mantle and the outer core are affecting the inner core, which is causing its spinning rate to slow down and potentially change direction. Before this study, scientists thought that the inner core was spinning faster than the Earth's crust. However, this new information suggests that the inner core may be slowing down due to the gravitational effect of the Earth's mantle and the magnetic field of its outer core. But here's where it gets even more interesting. When researchers took a closer look at data stretching all the way back to the 1960s, they discovered that the rotation of Earth's inner core was consistent from the late 1970s to the early 2000s. Before that, they found that another possible slowing down or reversal event may have occurred in the early 1970s. It's like the inner core spin is like a roller coaster ride, speeding up, slowing down, and possibly reversing course over a period of time. The researchers estimate that these switches occur every 7 decades or so, which is pretty wild. But why is it happening? Unfortunately, we still have no idea. The exact reasons for why the Earth's inner core sometimes stops and starts spinning in another direction aren't yet well understood. However, scientists believe that it may be due to complex interactions between the solid inner core and the surrounding molten outer core. A lot of different things can be at play here. The changes in the temperature, pressure, and composition of the core, as well as the movement of material within the core itself, and so on. Also, as we said before, the Earth's magnetic field and the gravitational forces from the surrounding mantle might also play a role here. We need further research to fully understand the mechanisms behind the inner core's rotation changes. So, is the world ending? Fortunately, no, not just yet. While the inner core is changing direction right now, it's not the end of the world as we know it. And even though findings may seem like a huge deal, life on Earth's surface hasn't been impacted much, if at all. In fact, it's just a fascinating part of the Earth's inner workings that we're learning more about every day. So, you can say with relief, nothing cataclysmic is happening. Moreover, according to Hervoya Kalsic, a geophysicist at Australian National University, the inner core is now more in sync with the rest of the planet than a decade ago when it was spinning a bit faster. All in all, this new study has added a strange twist to the story of Earth's inner core, and scientists believe that there's still much more to discover about this mysterious place. Who knows what other secrets lie in the heart of our planet? The possibilities are endless. So let's keep researching and enjoy our time on this amazing planet.
A space settlement floating out there in the cosmos. It's not sci-fi. But, as always, there is a catch. Look at this tiny deserted asteroid. It may look lonely and barren, but if you peek inside, you'll see life blooming inside of it. These days, many people now live right inside these asteroids. It's not sci-fi. According to researchers, we might be able to create futuristic cities the size of Manhattan on gigantic space rocks. Of course, there's a catch. The asteroid we choose as our base has got to be at least 1,000 feet wide. Though it's weird why life is inside this asteroid and not on its surface. You see, we can't really live right on asteroids. That's because we're not the little prince who indeed lived on an asteroid, according to the plot. but because there's too little gravity and too much radiation for us to handle if we chill outside. There are possible theoretical ways to stay on the surface, but it's going to be extravagant. So the only option is living inside asteroids. Nothing screams wildly theoretical like building an asteroid city. Living in space without any gravity isn't as romantic as it sounds. Researchers show that when people spend too much time in zero gravity, things start getting weird. Their eyeballs pop out, retinas detach, muscles shrink, and bones become as fragile as a potato chip. But imagine this: a space settlement floating out there in the cosmos. If you've watched enough sci-fi, you'd picture a massive structure spinning round and round. It spins to create gravity for all the lucky folks living inside. There's an actual prototype of this wizardry, the O'Neill cylinder. This device is named after physicist Gerard O'Neill, who came up with the idea for NASA in the 70s. Now, there isn't a ton of data on this, but humans need roughly 1/3 of Earth's gravity to function properly. An O'Neill cylinder may not be able to generate massive amounts of gravity, but the genius behind it, Mr. O'Neill himself, designed them to spin around their long axis. This device creates a gravity-like force called centrifugal force. So, if we ever get to use that, we'll be living happily on the inner surface of the cylinder, feeling pulled downward away from the center. But, as always, there is a catch. When the team crunched the numbers, they realized that the asteroids would break apart way before they could reach the speeds necessary to keep us grounded. And to make matters worse, most of these asteroids were more like loosely assembled piles of rock than a solid chunk. The small ones, like less than 6 miles across, are a mix of sand, pebbles, rocks, and boulders. They're all held together by the weak force of their own gravity. If you were to spin one of these asteroid buddies, all those parts would go flying off into space. Not cool. However, scientists didn't give up and they elaborated on the idea. They needed to find a way to keep the asteroids together. They played around with different ideas and they produced something crazy. Now, if you were to carry all your personal belongings every day right in your hands, at some point, the situation would be out of your control. You'd have to collect all your stuff from the floor. But you're smart and you carry a bag, right? Well, it seems that if we want to control an asteroid, all we need is a ginormous bag. But not just any bag, a massive, flexible, and super lightweight mesh bag made from teeny-tiny carbon nanofibers. These fibers are like tubes that are only a few atoms wide, but boy are they strong. So once we've got this cylinder-shaped bag all set up, we can start slowly spinning the asteroid using rocket motors deep within the rubble. And as it spins faster and faster, it'll start flinging all those pebbles, rocks, and boulders. And guess what? The carbon nanowire webbing is going to go flying out with them. This bag will be expanding and expanding until it reaches its absolute limit. And then the rubble inside slams into the now super tight webbing. It's like a crazy explosion of debris compacting together to create this massive hollow cylinder made entirely of concrete. Once all the dust settles, you can build entire towns, cities, parks, and even farmland on the inside of the cylinder. This is like something straight out of O'Neill's designs. You can even enclose the whole inner surface with a transparent roof. Outside of this incredible living area, you've got these thick concrete walls that are like superhero shields protecting against radiation. So not only do you have this space to live in, but you're also super safe from any harmful stuff outside. We still don't have this magic bag, as those magic carbon nanowires aren't mass-produced yet. But scientists claim that, according to the laws of physics, a tiny asteroid, like a few football fields put together, can be transformed into 22 square miles of living space. As of now, about 1.5 million people are living in Manhattan, and there are like tens of thousands of asteroids just hanging around in our solar system. You do the math. Seems like everyone will have a sweet spot to crash in space. Building a city in space is no easy feat. The main challenge still is to create a self-sustaining closed system that can keep going for the long haul. You see, cities on Earth rely on a much larger area to survive than just their own boundaries. But in space, The farther away from external resources a space city is, the more it needs to close its loops for oxygen, water, and food. Take the ISS for example. It's about 40% efficient in recycling oxygen, but even then, its CO2 levels are always sky high. NASA is on the case though, trying to figure out how to magically turn that CO2 back into oxygen. Once we've tackled the basics, like protecting ourselves from radiation, dealing with pesky gravity, and finding some air to breathe, it's time to get creative in space. Enter 3D printing and rocket engines, the dynamic duo that will pave the way for space settlements. With 3D printing, we can kiss goodbye to relying on Earth for spare parts. We'll simply whip them up locally, cutting out the middleman. We can even use 3D printers to whip up a delicious pizza in a couple of minutes. Of course, we'll need some fresh ingredients, but your dinner might just be a push button away in space. To truly thrive out there, we'll need to tap into the riches of asteroids. These celestial treasures are bursting with raw materials, perfect for creating solar arrays, building materials for our colonies, and so much more. And let's not forget about comets. These icy wonders are like cosmic water fountains, providing us with precious H2O for drinking, bathing, and even shielding ourselves from radiation. Plus, we can use that water to produce hydrogen and oxygen for rocket fuel and fuel cells. So, let's say we pull this off. Can you imagine people living or born in space might end up being different from you and me? Like if humans can have babies up there, these space colonies might develop some cool cultures. They might even come up with their own languages, and get this, they could even evolve new physical traits. It's wild to think that just after 300 years, a colony of 2,000 people could look and act so differently from us. They might have different hair textures, skin types, and even be taller or more slender to deal with that low-gravity situation. We might even develop new organs to protect us from cosmic rays. Or we'll have gill-like structures to breathe carbon dioxide. Hey, I know, it sounds crazy, but these scientists are working on developing these carbon nanotubes as we speak. So maybe one day we'll be living it up on our very own asteroid crib. It might seem like asteroid cities are just too far-fetched, but let's take a trip back in time for a moment. In 1900, no one had ever flown in an airplane. But today, thousands of people are zooming through the sky, comfortably seated in chairs, traveling at hundreds of miles an hour high above the ground, unaware that their luggage is on another plane going to a different destination. Ah well.
Let's talk about cyberpunk, a really cool genre of science fiction that started in the early 1980s. Its pioneer writers were really interested in how technology was changing society, especially with all the digital evolution happening at that time. One of the writers, Bruce Sterling, wrote an introduction to a book called Mirror Shades, which was like a guide to cyberpunk. He said that this genre is all about looking at technology in a new way, not just for science fiction writers, but for regular people too. It's like imagining a world where high-tech stuff and the cool underground culture mix together. The heroes of cyberpunk stories are mostly rebellious people who stand up against big companies and the boring mainstream. They believe in being unique and doing their own thing, even when the world tries to contain their efforts. These heroes are really good at taking things from popular culture and using them to express their own ideas and interests. They also know how to use computers to find out secret information and spread messages that go against the system. These days, cyberpunk themes are seen in more than just literature. You can find their influence in things like movies, video games, and even fashion. It does make you wonder though, could the future truly turn out to be what cyberpunk writers predicted? Truth is, all the cyberpunk literature is packed with mind-blowing technology that might just become a reality one day. Like augmented reality, for instance. Now this might sound far-fetched, but we're actually getting closer to experience AR in our daily lives. I mean, some companies are already offering such devices. Right now, they're mostly used for gaming and entertainment, but soon enough, we might use them for virtual training, education, and even shopping for a new car or checking out a house. Next up, smart clothes. In Cyberpunk video games, people are rocking these stylish garments that not only look cool, but also offer some serious protection. We're not quite there yet, but smart clothes are becoming a thing in our world too. You've probably heard of smartwatches and fitness trackers, right? Well, imagine clothing that can monitor your body's movements, suggest healthy habits, and adjust your body temperature. Some fashion brands are already exploring this exciting field. Now let's dive into virtual reality. In one particular Cyberpunk story, there's a feature where you can customize your own virtual reality experience. It's like stepping into someone else's shoes and reliving their memories. Now, VR is already pretty amazing in our world. We use it for medical purposes, gaming, and tourism. And here's something even cooler. Imagine being able to feel things in virtual reality. Yeah, it's called haptic technology, and it's being developed to make VR even more immersive. You could use it to control machines, learn in a virtual classroom, or even attend a concert with friends who are miles away. Last but not least, we have artificial intelligence. In a cyberpunk scenario, AI is everywhere, from brain analysis to taxis with intelligent controllers. Now, we might not have all that advanced AI just yet, but we're definitely making progress. You're probably familiar with all those virtual assistants featured on smartphones. Well, imagine them getting even smarter. AI is expected to be integrated into so many aspects of our lives, like fridges that can automatically order groceries when we're running low, self-driving cars, and delivery drones. And hey, AI is already helping companies suggest personalized content based on certain preferences. In the future, it might even help us find the perfect recipe for dinner or recommend the ideal cosmetic product just for us. Then, there's the potential for a brain-computer interface, or BCI for short. In a cyberpunk world, it's like a special connection between our brains and the internet that would allow people to virtually explore using just their minds. In the real world, scientists are already working on developing BCI systems. They can read the signals from our brains and turn them into commands. So instead of using a keyboard or a mouse, we might be able to control objects just by thinking. Right now, these BCI devices are being used in research settings, but someday they could be used to support people. They could help with regaining useful functions and improve rehabilitation. It doesn't stop there, though. BCI could also help professionals like pilots and surgeons. It could make their natural skills even better and help them do their jobs with even more precision. But, there are also some things we need to be careful about when it comes to this cyberpunk technology. In the cyberpunk world, there are serious problems to consider. One of the concerns, for instance, is that if we rely too much on technology, it might start making decisions for us. We might become less skilled at day-to-day tasks because we let the machines do everything for us. That's why we should focus on using our own resources to make our own choices. Another thing we need to watch out for is protecting our information. All sorts of security breaches are already happening all over the world. We need to make sure we have strong measures in place to keep our information safe. Science and technology are moving at an incredible pace these days. It's hard to pinpoint what the future might look like, but you surely have some sort of scenario in mind. Maybe you envision a world where robots and AIs, controlled by a handful of powerful corporations or individuals, dominate the scene with unjust power structures. Or perhaps you picture sprawling cities filled with skyscrapers and flying cars, shrouded in perpetual darkness. And maybe the future seems bleak, where only a privileged few have access to nature, while the rest struggle to make ends meet on a harsh planet. In the cyberpunk world, our planet is either on the brink of a disaster or has already fallen into complete ruin. The stories consistently revolve around dominance and control, whether it's between the rich and the poor, corporations and the market, or humans and the AI robots they create. Cyberpunk is all about systematic and oppressive inequality. It's also about a future where most humans live in a highly mechanized society that disconnects them from the rest of the natural world. In this potential future, all the amazing technologies we've created don't really improve the lives of most people. In fact, they make things worse. It's not all bad, though. Sci-fi can be more than just entertainment. It has a way of inspiring and shaping our real world. Throughout history, designers have drawn inspiration from sci-fi for inventions for things like flip phones, self-driving cars, and even the concept of the metaverse. There are also many interesting alternatives for the future. Ever heard of solarpunk? It's also a genre of speculative fiction, but one that envisions technology and the environment evolving together. The solar part is all about the power of solar energy, while the punk part puts it in the same awesome group as other sci-fi genres like cyberpunk. So what does solarpunk actually look like? Well, imagine visually stunning utopias that are all about the environment and being positive. In solarpunk worlds, they've totally sorted out how to correctly use the planet's resources, or are actively working together to fix it. It's all about coming together and being friends in the fight against a bleak future. When you enter a solarpunk universe, you'll be greeted by groovy green tech, cities that are super walkable, and tons of lush greenery. It's all about living in harmony with nature, while still rocking the latest technology. It's like the complete opposite of cyberpunk, which is all about grimy cities, greedy corporations, and fear of outsiders. Solarpunk is all about putting people first and recognizing the amazing connection between human intelligence and the Earth. One of the major influences on solarpunk is Art Nouveau. This art movement is all about embracing organic and earthly shapes, and it fits perfectly with solarpunk's vibe. Another cool reference for solarpunk is the arts and crafts movement from the late 19th century. It was all about rebelling against unnecessary waste.
Okay, so you've seen the movies and read the books on time travel. Most of them tell stories about entering some futuristic boxes, and in the blink of an eye, you're in some different epoch. For now, this is just sci-fi. But there are ways to make time travel possible, at least theoretically. We just don't have the technology figured out yet. For starters, time travel to the future could be achieved by traveling at high speeds, but not just getting a ticket on the superhighway kind of speed. This is based on Einstein's theory of special relativity. It explains that time slows down for objects that move at really high speeds. And the good news is scientists have already tested this theory, and it looks promising. They did it with the help of two identical clocks. One was placed on a jet, and one stayed on the ground. They found that the clock on the jet ticked slower than the one on the ground because of how fast the jet was moving. The faster an object is moving, the more time will slow down for it. Currently, the fastest speeds achieved by human technology are seen in a special type of particles called neutrinos. Some of these can move at almost the speed of light. At these speeds, 1 second for the protons is equal to 11 months for us. Now, we might be able to time travel to the future with the use of gravity, too. This idea is based on Einstein's findings, namely his theory of general relativity. Now, this theory explains that the stronger gravity is, the more slowly time moves. This means that as you get closer to the center of the Earth, the strength of gravity increases. And if you think about it like that, time actually passes more slowly for your feet than for your head. Now, is that why I'm always late for stuff? Good excuse. This effect has been measured too, with the help of the same strategy with two identical clocks. Scientists placed them on shelves at different heights and measured the rate of ticking. The clock on the lower shelf ticked more slowly because it experienced a slightly stronger gravity. But this option comes with a catch. To be able to travel to the far future, you'll need to find a place with extremely strong gravity, like a black hole. That's a point in space where the gravity has so much force that even light cannot escape it. There, gravity becomes so intense that matter gets squeezed into a tiny space. The closer you get to the black hole, the more slowly time moves. However, traveling via a black hole is very dangerous, mostly because it's a one-way ticket. Once you cross its edges, there's no coming back. Now, here's a fun fact. The GPS systems we use on our phones and in our cars already have to account for time dilation effects in order to work properly. That's because of the speed of the satellites they use and the gravity they feel here on Earth. Without these corrections, your phone's GPS wouldn't be able to pinpoint your location on Earth very precisely. Meanwhile, the third option has less to do with the universe's unknown forces and more to do with our own bodies. Scientists are trying to find ways to time travel to the future by slowing down the body's own processes. It's not time travel per se. You wouldn't technically be going anywhere. But if your body stays put for a long period of time, you could eventually wake up in the future. Some animals, like bears and squirrels, can slow down their metabolism during hibernation, which means they don't need as much food and oxygen to survive. Specialists are trying to figure out if humans can do the same thing. They're working on ways to make people go into a short-term hibernation for a few hours to begin with. This could be helpful for medical emergencies too, in order to help a person before they can safely get to the hospital. In 2005, scientists were able to slow down the metabolism of mice by exposing them to a small amount of special gas. However, when they tried to do the same thing with larger animals, it did not work as effectively. Our fourth option of traveling through time is really unique. It involves a special type of shortcuts that may exist in our universe called wormholes. Now, before we move on, let's try to understand what they are. You'll need to picture two balls and a trampoline. If there's no pressure applied on the trampoline, it stays flat. Now imagine the two balls placed on the trampoline symmetrically. If you look at them from this perspective, there's no possibility of them ever touching. But if you put enough pressure on the trampoline between the two balls, this flexible fabric can stretch so much that the two objects might potentially touch each other. The same thing happens with stars in different star systems. They're big enough to curve space around them. That's why most planets tend to orbit around a star. The tunnel between those 2 points would be a wormhole. These wormholes could be used to travel long distances, like 1 billion light-years, or even visit different times. Now, many scientists, like Stephen Hawking, think that wormholes might appear and disappear, but be very small, smaller than atoms. The problem is that we don't know how to catch one and make it bigger so that people can use it. This would take a lot of energy, and we don't know if it's even possible. Some astronomers say that even if we could find a wormhole and enter it, it would rapidly collapse on itself. Even the tiniest bit of extra mass, like that of our bodies for example, can result in the wormhole slamming shut, like a rubber band that's been stretched too much. Now, the fifth solution for time traveling was proposed by an American physicist named Ron Mallett. It involves one resource that we know for sure is abundant in the universe: light. The scientist proposed a theory about time travel that would use a rotating cylinder of light. He believes that if something was dropped inside this swirling cylinder, it could be moved in both space and time, similar to how a bubble moves when you swirl it with a spoon in your coffee. According to Mallett, the right shape of the cylinder could allow for traveling to both the past and the future. The physicist has been trying to raise money for an experiment to test his theory. This experiment involves dropping tiny particles, called neutrons, through a circular arrangement of spinning lasers. However, other scientists say Mallett's theory is impossible and there's no need to test it further. Well, even if we eventually figured out a way to travel back in the past or to the future, would it be safe? Scientists have been talking about a problem called the paradox of time travel for a long time. The main question is what would happen if you went back in time and did something that changed the future. However, a new study from researchers from the University of Queensland says that this problem might not be real after all. The scientists have done some calculations and found out that even if you had changed something in the past, the timeline would still end up the same way. Another variation of this problem is called the grandfather paradox. Imagine going back in time and preventing your own grandfather from having offspring. Come to think of it, it automatically means you shouldn't exist in the first place. If your grandparents didn't have your parents, how can you exist at all? Well, these days scientists are certain that even if you did experience something like that, you'd still exist in the present. That's because the timeline that already exists has a way of adjusting itself. regardless of where people are in time and what they do. Or somehow get 1.21 gigawatts in a DeLorean and make like Marty McFly.
Have you ever wondered how cool buildings of the future are gonna look? Well, hold on tight because artificial intelligence is here to revolutionize the world of architecture. AI is a great sidekick. It can give the architects incredible new tools to create mind-blowing structures that are not only stunning, but also eco-friendly and super efficient. So let's check what our beautiful future might look like. First of all, you know how cities can get crazy busy and overwhelming, right? Well, guess what? AI is here to save the day and make our cities super smart. Imagine you're cruising down the road in your flying car. Yes, we'll have those. Thanks to AI, the traffic flows like a dream. No more endless gridlock. The city knows where the most likely crime spots are and takes proactive steps to keep us safe. It's like having superheroes on every corner. And hey, forget about trash piling up. AI makes sure waste is managed efficiently, keeping our city clean and fresh. They can act as a city manager who can optimize everything from traffic to safety and even waste disposal. They can analyze tons of data from all sorts of places like sensors and social media. With all that information, they can help city planners make brilliant decisions that make our lives better. Okay, so you stroll down the street, and your eyes are instantly captivated by an extraordinary building. Its futuristic curves and features make it stand out from the rest. And it not only catches your eye, but also gives Mother Nature a high five. You might think it was designed by a genius architect, but little do you know it was actually a collaboration between humans and artificial intelligence. Imagine having a super smart design buddy who can whip up thousands of incredible building ideas in a blink of an eye. That's what AI-assisted design software does for architects. It can generate and assess a ton of design options. They take into account stuff like the best materials to use and the perfect placement for the building. Also, by analyzing data and crunching numbers, algorithms can help optimize the building's design. They can ensure it minimizes energy usage, conserves water, and manages waste like a pro. Every building strives to reduce costs, save energy, and promote a better world. The result? Architectural masterpieces that are both jaw-droppingly beautiful and super practical. The cityscape of the future will be dotted with these awe-inspiring structures. Oh, but that wasn't impressive enough for you? Well, how about a stunning, futuristic building that seems to defy gravity? It's not made of traditional bricks and mortar, oh no. This marvel was created using the powers of 3D printing. With the help of AI, architects designed every intricate detail and fed all the important data, like what materials to use and how the site conditions might affect the structure. AI algorithms worked their magic to optimize the design, making it both breathtakingly beautiful and rock solid. 3D printing is basically like having a magical machine that can create awesome structures straight out of a sci-fi movie, and AI jumps in to make sure these structures are not just pretty, but also strong. In the city of the future, 3D printing will become the ultimate architect's tool. It will allow them to create structures that were once impossible to build. From mind-bending shapes to intricate details, the possibilities are endless. But AI isn't just making buildings look great, it also makes them efficient and cozy. Let's say you step into a futuristic office building, and voila! The lights automatically adjust to match your mood, and the temperature is set perfectly for you. These futuristic buildings are capable of sensing and responding to their surroundings, just like you do. They control the lighting, keeping it just right for the time of day. They manage the temperature, so it's always cozy and comfortable. They even keep a watchful eye on security and fix small issues before they become big headaches. So, the smart building knows when people come and go, so it optimizes energy usage accordingly, saving the planet and some cash along the way. Now the cool thing is, all these aren't the only possibilities. How about turning skyscrapers into a vertical forest? Recently, an architect from India got super excited about the power of artificial intelligence. So, he decided to team up with an image bot called Midjourney to create a vision for the future. But instead of a dull, robotic world, they aimed for something spectacular. With text prompts like utopian technology and futuristic towers, the architect and AI got to work. Guess what? Midjourney didn't disappoint. It conjured up a world where buildings were covered in lush vertical forests, and adorned with shapes inspired by nature. They wanted to create a sustainable future that harmonized with the environment. The architect, Manas Bhatia, is super positive about AI's potential. He doesn't see it as a threat to his job, but as a powerful tool for positive change. He envisions a future where architects and AI collaborate to make breathtaking designs. In his project, Bhatia even asked the AI to imagine symbiotic and hollowed structures, and it responded with pictures of apartments nestled within hollowed-out trees. Imagine a world where the building itself becomes a living, breathing part of nature. Well, Bhatia believes that nature should play a big role in architecture. He loves designing structures that embrace nature's beauty and functionality. From buildings built around trees to facades that regulate temperature, he's all about blending architecture with the natural world. With architects like Bhatia and the superpowers of AI, the future of cities is going to be amazing. So get ready to step into a world where nature and technology coexist in perfect harmony. It's a dream we can't wait to see come true. Or if you're not a big fan of trees, how about this? Skyscrapers that aren't made of solid bricks, but instead, they're inflatable wonders. Zumo, an architectural practice in Barcelona, used the magic of AI to bring these wobbly structures to life. These inflatable superstructures rise above future cities like illuminated balloons in the sky. Here's the best part. These inflatable buildings have sustainability superpowers. You can pump them up to towering heights, flatten them for easy transportation, and rebuild them wherever they're needed. Plus, they're powered by renewable energy, reducing their impact on the environment. Pretty cool, right? Phew. The future is zooming toward us like a rocket. Artificial intelligence can become the secret sauce that makes architects' work extra special. But hey, with great power comes great responsibility. We need to use AI wisely and ethically. For now, we don't have to worry about machines replacing architects. Artificial intelligence still needs a human hand, or else we might end up with buildings that look like mashed up bananas or ice cream cones, unless that's your thing. In addition, humans have one important advantage. They, well, are humans. We need to keep in mind that artificial intelligence doesn't have emotional intelligence. It's a brainy genius, but it can't fully understand the feelings and vibes we humans crave in our spaces. So, we must remember to infuse our designs with that human touch, those warm and fuzzy elements that make us go, "Ah, I feel right at home." And let's not forget that AI is still learning. It's basically just taking its first steps, and we need to be patient and give it time to grow. Rushing things too quickly could lead to wonky designs or buildings that look like a jumbled puzzle. This might look cool if you like avant-garde architecture, but for regular folk, no thanks. So, as the future unfolds at warp speed, let's embrace the wonders of AI in architecture. But let's also remember to balance its brilliance with our own human touch. Together, we can create a future where buildings are not just functional, but also filled with heart and soul. It's an adventure that's out of this.
Look up when the sky is clear at night. You'll see thousands of tiny bright dots there. It may seem like they're fixed in one spot, but in reality, they're constantly moving. In 100,000 years, there won't be a constellation with the same shape or pattern we know today. And think about all those red dwarfs, small stars, planets, space bodies we can't see with the unaided eye. Red dwarf stars are especially cool. They're usually about half the size of our sun, and mostly 1/10 as bright. They may not be the brightest things in the sky, but they live for a very, very long time. Nuclear fusion reactions happen deep in star cores. That's what makes them shine. Large stars release huge amounts of energy, burning their stellar fuel. But such stars tend to burn all their fuel in only a couple of million years. Stars like our sun usually live for about 10 billion years, but red dwarfs don't use that much of their fuel. Their light is not so powerful, and they don't require much energy to support their existence. They're like energy-efficient cars. That's why they can last hundreds of billions of years. Some of the smallest ones may live for up to 10 trillion years. Most hydrogen in sun-like stars remains unspent. There's more of this gas in the atmosphere rather than in the core of such stars. This means most hydrogen doesn't take part in the fusion reactions. But it's different with red dwarfs. They circulate plasma throughout their entire bodies. These stars pull fresh hydrogen reserves from their outer layers into their core. That's what keeps fusion reactions running. One day, in the distant future, stars like our sun will run out of fuel and shut down. the universe will be full of small red dwarfs. They won't have enough energy to shine and brighten the space around them. Our descendants, if there are any, will inherit a dim, dark cosmos. As it gets older, the sun will balloon to a size where it will destroy nearby planets. First Mercury, then Venus, and then us. On the other hand, Earth will probably survive, but barely and not for long. The sun will burn it to a crisp when it gets closer. The outer planets of our solar system will also survive, but they'll move even farther away into space. The sun will lose some of its mass while increasing in size. Its gravitational pull establishes the orbits of the planets. When our star becomes less massive, the pull of its gravity will become weaker, and the outer planets won't have such a strong connection with the sun. Our solar system is not isolated. There are many other stars in our galaxy. Within 30 billion years, stars that travel nearby will mess with our outer planets enough to rapidly launch some of the biggest ones out of the solar system altogether. The last planet to stay will stick around for a while longer, maybe even 100 billion years. But even that one will eventually end up kicked out of the solar system. There's a theory claiming that we got most of the water on our planet from ice-laden meteorites and comets, frozen balls of ice and dust. As they crashed into the early Earth, they probably brought water, which was necessary to develop life. But those very same objects that might have created life on our planet could also be its end. This is not a matter of if, more a matter of when. And scientists think it's very likely that an asteroid or comet big enough to wipe out life on Earth will smash into our planet. But it'll happen in the distant future. And fortunately, we have the technology to predict such things and react on time. But there are other cosmic collisions we can't avoid, no matter what we do. Andromeda, our neighboring galaxy, is moving toward the solar system at a speed of 68 miles per second. There are 2.5 million light years between the Milky Way and Andromeda, so luckily our neighbor won't cover that distance anytime soon. It'll only happen in around 4 billion years. Such a collision of two galaxies might lead to real chaos for our descendants, if any of them are still living on Earth, that is. The two galaxies will slide past each other. Then they'll draw apart until the gravitational force starts pulling them back together. As they merge, they'll both lose their disk-like structure and form one big elliptical galaxy. It's already got the nickname Milkomeda. The Milky Way as we know it today won't exist anymore. Space is in constant motion, changing all the time. Scientists have a couple of possible scenarios of what might happen with the universe in the future. Number 1, the Big Rip. This theory claims that the universe will expand infinitely. At one point, the pull of the expansion will get stronger than the gravitational force keeping it all together. If this happens, it will tear apart galaxies, stars, black holes, and all other space bodies, including Earth. The universe will turn into a bunch of disconnected particles. Until about 5 billion years ago, the universe was expanding slowly because of its powerful gravitational pull. Then its growth sped up. Some experts say it happened because of the effects of dark energy. Dark energy is a mysterious force that makes up almost 70% of our universe. This force pushes it to expand faster rather than slowing it down. So, in the case of the Big Rip scenario, dark energy will win over gravity to the point where it will be able to rip apart individual atoms. Scenario number 2, the Big Crunch. There's a possibility the universe will get to the point where it'll stop expanding. Gravity will become a dominant force. It might even reverse the expansion of the universe. Then, the cosmos will start shrinking, making planets, stars, and even entire galaxies collide. In the end, the whole universe will collapse in on itself. Once everything compresses into one infinitely small point, which is something called the Big Crunch, the universe may start expanding once again. Theory number 3, the Big Freeze. Brr. In this scenario, entropy will grow until it reaches its maximum value. Entropy is basically the idea that everything in the universe declines into disorder at some point. Once entropy gets to its maximum, the heat in the system will be spread evenly. The universe will then disappear because there won't be any room for heat to exist. Any mechanical motion inside the universe will stop. The cosmos will be so empty and gas will be so thin that no new stars will be able to form or shine again. In such a cosmos, Time is just an endless void. Nothing ever happens with planets, stars, or living beings. The entire universe is frozen, dark, and motionless because there's no energy that can make things start working again. Many, many billions of years after the last stars burn out and fade, black holes will send a message that the universe has come to an end. Black holes are areas with extremely strong gravitational pull, so powerful that nothing can escape it. They can be as massive as 100 suns. As for supermassive black holes, their mass can be greater than that of 1 billion suns. You can find such giant black holes at the center of most galaxies. Like everything else, black holes will experience the same end. But when their moment comes, they won't gently disappear into the night. Black holes will go away in enormous bursts of fireworks, lighting up the universe in the last moments of their existence. It will be the end of the entire era. Black holes usually survive by gobbling down the stars and gas that come close enough. Their gluttony is the main feature that gives them away. In most cases, there's an accretion disk around a black hole. That disk is made of all those materials and particles it's torn apart and is pulling inside, similar to when water swirls down a drain. As the materials and particles draw closer, they start to move faster and faster. This generates heat, which makes the accretion disk glow, which again gives away the black hole. Yep, black holes aren't that great at hide and seek. Things that cross a black hole's event horizon, which is also called the point of no return, are lost forever. But Stephen Hawking had a theory that you might be able to escape from a black hole. There are particles moving even in a vacuum. Let's say one particle has positive and one has negative energy. If they both come close to a black hole, there's a chance that one will fall into it while the other will escape. That means the black hole has radiated the particle away. And this particle has taken some of the black hole's mass with it, which is why the black hole may start shrinking. As it begins to evaporate, it loses its mass and slowly becomes smaller. More and more particles start leaving until all the energy that's left behind escapes all at once. In the final tenth of a second, there will be a giant flash of energy and light in a very, very small region of space. And then, it's all gone.
Okay, here you are in the middle of the ocean. It's endless, but you can't see it because there's a thick fog all around you. Dense clouds hide the huge but dim sun. Is it day or night? You don't know. There's only a gray haze around you. You're alone. Even if you try to swim down, after several hours, you still won't be able to see the bottom of the ocean. And that's a typical water planet for you. I know, sounded kind of dark, but it's not that bad. These water worlds are more interesting than they may seem, so let's take a look at them. The ocean planet is a planet that consists, as you might have guessed, mainly of water, ice, and maybe some rocks. Think of the Earth's oceans. Its horrifying depths, the Mariana Trench, and all that. And now, can you guess how much space all the water on Earth takes up? 0.025%, exactly. Now, just try to imagine a world of 40 to 60% water. If you dive in there, the depth can exceed 60 miles. Compared to that, the 6-mile depth of our Mariana Trench sounds like nothing. And yeah, the pressure there will be enormous. It can reach up to 20,000 Earth atmospheres. Very crushing. Now, it may sound scary, but it still would be great to find out more about these planets. Fortunately, according to scientists' calculations, there may be a lot of such planets in our galaxy alone. Well, you don't have to go far. You can find these water guys even in our solar system. Not planets, of course, but moons. Jupiter has Ganymede and Callisto, and Saturn has Titan and Enceladus. The ocean can reach up to 30% of the mass of these moons, although it isn't clear whether these oceans are covered with a thick crust of ice. But we've discovered quite a few full-fledged ocean planets. This is because the conditions in which these planets may exist are very specific. For example, this planet should be somewhere 6 to 8 times larger than the Earth. If it's smaller, it'll have a rocky surface. But if it's bigger, it'll turn into a gas giant. At the same time, it must be in the habitable zone of its star. A little further, and the planet immediately turns into an icy giant or a cold super-Earth. So yeah, these guys are very picky. We first started exploring these planets back in the 1970s. However, since then, we've found only a couple of them, but they're still very interesting. The first planet is Gliese 1214b. It was the very first ocean planet that we discovered. Initially, the scientists noticed only a small dim dot. This dot turned out to be the red dwarf star Gliese 1214, an unremarkable, completely ordinary star that's 5 times smaller than our Sun and 300 times dimmer. Scientists wouldn't worry about it at all, but back in 2009, they noticed that this star had one single planet, and this planet turned out to be quite strange. This super-Earth was 2.5 times bigger than our Earth and 6.5 times heavier, but at the same time, it had a very, very small density and about the same gravity as our planet. In other words, there were almost no rocks and metals on it, but it wasn't a gas giant either. So there was only one option left. It was covered in water and ice. And that's how we discovered the first ocean planet. Well, actually, we can only assume that it consists of water. That's what the mathematical calculations say. In reality, this planet is quite confusing. It's difficult to explore, and so far, scientists haven't been able to find anything there. No hydrogen, no helium, no water, nada. That's because the outer layer of the atmosphere of this planet is very dense, and it perfectly hides its composition. But even so, it's probably a water world. Gliese 1214b is very close to its star. It's only 0.014 astronomical units away, which is less than the distance between the Moon and us. The year there lasts about 36 hours, and the temperatures, to put it mildly, are just wild. Scientists suggest that the average temperature there can reach 250 to 535 degrees Fahrenheit. Woo, that's hot. Remember the creepy description from the beginning? Well, actually, spending time on Gliese 1214b would be a little different, more like swimming in a steam boiler. Because of such gigantic temperatures, the ocean on the surface will be constantly in a state close to boiling without actually reaching it. So, imagine that you're descending to the surface of this planet, flying through clouds of steam, and then you suddenly find yourself in the water. What? But when did it happen? Well, that's because the boundary between steam and water on Gliese 1214b will be very blurred. Of course, you won't be able to swim to the bottom of this ocean, but most likely, this bottom is covered with a very thick layer of so-called hot ice. It's like regular ice, but it doesn't really care about the laws of physics, so it just doesn't melt even at gigantic temperatures. And the thickness of this ice can reach as much as 3,000 miles. So that's it for the creepy Gliese 1214b, and not an Airbnb in sight. Now, although we can't 100% guarantee that it's a water world, we still have another candidate for this position. A newly discovered planet called TOI 1452b. This planet, located in the Dragon constellation, is almost 100 light-years away from us. It was discovered using the TESS telescope by a group of researchers from the University of Montreal. This planet also belongs to the class of super-Earths. It's 7 times larger than our planet, but 48 times heavier. Again, all this is at a very low density. Because of this, scientists have suggested that almost the entire planet consists of a giant ocean. Here, we were a little luckier. This world won't be just a giant puddle and some thick ice. On this planet, there's probably a rocky surface deep under the water, just like in a typical ocean. Don't get too excited though, this ocean will certainly be very different from what we're used to. TOI 1452b also orbits a small red dwarf, and not even one, but 2 at once. At the same time, if the previous planet was close to its sun, then this one, on the contrary, is very, very far away. It's 2.5 times farther from its stars than Pluto is from the sun, and it moves at great speed. A year there lasts only 11 days. But we still don't know many things about this planet. We'll probably get some new information when scientists observe it from the James Webb Telescope. Well, that's it. Wait, did you expect something else? All right, I know the question that bothers you the most. Can there be life? Well, this is a difficult question. We all know that water means life, and besides, these planets are in the habitable zones of their stars. So, potentially, yes, there might be life. Not some full-fledged civilizations, of course, but bacteria, fish, and some creepy giant monsters. I mean, why not? However, this is very unlikely. Water alone isn't enough to create life, even though it's very important. There should also be some microelements and some minerals. And unfortunately, for most water planets, the composition will only consist of water and very thick ice. There won't be any minerals there. But don't give up. There's still some probability. First of all, there are meteorites and comets. They can bring the necessary minerals to the planet. The more often they crash into it, the higher the probability that they'll bring something like this into the ocean and thus create life. Secondly, TOI 1452b actually has these minerals. Yes, we don't know how deep the rocky bottom is located there. But if it exists, then surely something could have originated there. Let's hope that new research with powerful telescopes will allow us to find out the truth. And who knows? Maybe one day we'll be able to visit such a planet ourselves.
Is it possible for a planet to have not one, not two, but many suns? Let's imagine what would happen to us if the sun suddenly decided to break into a bunch of small stars. During the search for Earth-like planets throughout the universe, scientists have discovered that systems of 2 or even 3 stars are not actually that rare. Many of them even have planets in their habitable zones. Almost half of these planets could contain life. Can't wait to ask these guys about the sunsets. Scientists even suggest that our sun wasn't always lonely. It could have had a companion star called Nemesis. They've noticed that mass extinctions on Earth occur every 27 million years. It's like a cycle. So, they turned to the stars to find out what the reason might be. And then, they assumed that it was a star that left our sun a long time ago, but it still affects us. Nemesis could be located about 1.5 light-years from us. It may not sound like a lot, but it's actually almost 9 trillion miles. That's gonna be a fun car trip. 50 million years long. Anyway, every time Nemesis passes its orbit, it can affect the Oort cloud. The Oort cloud is an area surrounding our solar system in which comets are formed. Its existence hasn't yet been proven, but scientists are pretty sure about it. So, comets form inside this cloud and then relocate to our solar system. Even being very far away, the second star in the system can have a great influence on it. But what about systems with 4 or even more stars? Is it even possible? Actually, yeah. But the more celestial bodies you add to the system, the more difficult it becomes. The orbits grow unstable. It's gonna be as chaotic as can be. In stellar mechanics, it's called the 3-body problem. It says that it's very difficult to predict the orbits of bodies in such systems. In most cases, they turn out to be very random and unique. Isaac Newton was the first to have noticed it. He tried to apply his gravitational discoveries to the Earth, the Moon, and the Sun. He found himself with quite a struggle. It wasn't easy to understand how 3 stellar objects orbit so stably around each other. And that's just a planet and a satellite. How about including several stars? I wouldn't envy those who'll have to calculate all this. Oh, right, it's me. Anyway, we know that triple star systems are ridiculously chaotic. But what about systems with more stars? They're very, very rare. In 2021, NASA discovered a star system of as many as 6 stars. That's just crazy. Of course, there are no planets in it, but who knows? Maybe one day we'll find such a system too. In such worlds, the gravity dance is very complex. It takes very specific conditions to hold everything together. It's like walking on a tightrope over an abyss. With all this in mind, let's try to imagine what would happen if the sun suddenly turned into several small stars. Oh, we're going to need a very detailed simulation. No, probably even a dozen simulations to make this thing work, because otherwise, we'd only have a few options. Option 1. We divide the sun into 5 to 10 tiny suns. Now we'll scatter these guys not far from each other. They'll destroy our system in a couple of hours. Yeah. All star systems, including ours, are in constant motion across the universe, so they'll crash into each other almost immediately. This collision will lead to the creation of a supernova. Our system will turn into a beautiful, colorful nebula. For us, it will happen in just a couple of minutes. We won't even have time to feel anything. And all the planets in the X solar system will immediately turn into sparkling space dust. But it's not the best option for us, right? Let's see if it can go any other way. Option 2. Since they can't be located so close to each other, let's try to set them as far away as possible. And in this case, they'll just leave. Bye-bye. Their gravitational force is too weak to hold everything together. The little suns will simply leave the solar system, flying into space in random directions. After that, the rest of the planets will descend from their orbits, including poor little us, of course. We'll become a so-called rogue planet. At first, we won't even realize that the planet has gone out of orbit, and we won't have time to do anything before it gets incredibly cold. What a sad and poetic end. In general, none of these outcomes sounds very fun. Oh, alright, we still have the last option. Our main problem is that we make each of these little stars the same mass. But just take a look at all these multi-star systems that we've already discovered. You'll see that none of them look like a bunch of glowing balls together. Instead, there are a couple of large stars there, and the rest, the small ones, are orbiting around them. So how about 2 large stars and 2 small ones? What will the Earth look like then? Well, its orbit will become terribly unstable. We'll shake back and forth. Wouldn't recommend it, honestly. We know what this can lead to because, and that's just crazy, this has already happened to us once. Yes, about 70,000 years ago, a lone star visited our solar system. It was a red dwarf called Scholz. A red dwarf is a very small and cold star, if you count 14,000 degrees Fahrenheit as cold, of course. But it's considered the weakest and coldest type of star, so it probably didn't look that big and bright in the sky. At that time, our ancestors, Homo sapiens, were already there living their lives. And can you imagine? They saw another star in the sky approaching the sun. I wonder what that looked like. And then, Scholz bypassed the sun and flew somewhere further to surf space. You weren't expecting some kind of disaster, were you? If it had happened, you wouldn't have had a chance to watch this video right now. But from this story, we can see what happens to the Earth during such stellar events. At that time, a huge amount of volcanic activity unfolded on our planet. We also got some meteor showers that almost wiped us out. Our ancestors sure had it rough. Something similar will happen on our hypothetical planet with 4 suns, but on a much greater scale. Constant volcanic activity, earthquakes, and tsunamis. Brr. In addition, the length of a day will change, as well as the length of all seasons, and a year as a whole. They won't be stable anymore due to the regular changes in gravitation. In other words, you'll never know when to expect an annual winter or hot summer. And when we are precisely in the middle between 2 stars, there won't be any nights at all. They'll illuminate both parts of our planet, and we'll have to sleep in bright sunlight. And if you think this is a bad thing, keep in mind that we'll also be attacked by much more ultraviolet rays and solar winds because of our 4 suns. Their color will also change. They'll become red dwarfs, looking distinctly orange-scarlet in the sky. We'll also get many more solar eclipses, except instead of the moon, the sun would be eclipsed by another sun. It would probably just get a little darker. To be honest, it's unlikely that anything would survive on Earth after all this. I mean, it is possible, but please run 100 simulations yourself if you want to make sure. But theoretically, we could survive in a simple binary star system. For example, in one that consists of 2 stars close to each other. Each of them would have to be 2 times smaller than our sun. That would be the perfect scenario. And it's quite possible in the future. NASA is currently working on a plan to relocate our descendants to Proxima Centauri b. That's a planet near the closest star system to our sun, Alpha Centauri. And who knows, maybe one day in the future, we'll really move there. Then we'll see what it's like to live with several suns.
Imagine that it's the year 2025, and our planet has completely changed. Rising sea levels, extreme weather, and the ocean becoming more and more acidic are just some of the problems people have been dealing with for years. But in one of the world's largest coastal cities, the situation has become too serious. It was a sunny day in June when a massive earthquake shook the city to its core. The ground beneath people's feet heaved and shook, and buildings swayed dangerously. People ran through the streets in panic, trying to find safety. But as soon as the ground settled, the inhabitants of the city realized the real danger. A wall of water, almost 100 feet high, was rushing toward the city, propelled by the force of the earthquake. The tsunami hit the city with unimaginable force. Entire neighborhoods were wiped out, and thousands of people lost their lives. But here's where things get interesting. In the aftermath of the disaster, the city's authorities realized that they couldn't just rebuild the city as it was before. They needed to be better prepared for the next potential disaster. And so they came up with an incredibly ambitious project to build an underwater city. The goal was to create a self-sufficient, sustainable city beneath the ocean's surface that could withstand any natural disaster. The underwater city would be powered by renewable energy, using tidal power and underwater solar panels. It would be designed to withstand extreme weather and would have its own emergency response systems. The project attracted some of the world's top scientists, engineers, and architects. They worked tirelessly to design the city and carefully considered every aspect of the project. The underwater city would have everything that a typical city had, from schools and hospitals to stores and restaurants. There would be underwater farms where fish and other marine creatures could grow. The city would even have its transportation system, advanced submarines, and underwater tunnels connecting different parts of the city. The project became a shining beacon of hope for people. It showed that even in the face of disaster, we could come together to create something amazing. But as time went on, the project no longer seemed so perfect. The cost of the project turned out to be higher than planned. There were also concerns about how long such a project would exist. After all, the ocean is very unpredictable. And still, the team of scientists and engineers never gave up. After years of trial and error, they finally created the perfect underwater city, a marvel of engineering, a self-contained ecosystem that could sustain people indefinitely. The buildings were constructed from a material that could withstand the immense pressure at the bottom of the ocean, and the city itself was powered by a network of advanced hydroelectric turbines. It wasn't long before the first wave of colonists arrived at the underwater city. There were different people in this group, and each of them had their own reasons for choosing to live in this new world beneath the waves. Some were adventurers seeking a new world to explore, while others were hoping to escape natural disasters raging on dry land. But despite their differences, all these people shared a common goal: to build a new society, one that was in harmony with the natural world. The underwater city flourished, and new discoveries were made every day. The colonists developed new technologies and ways to tame the power of the ocean. They learned to farm the sea and started cultivating underwater gardens that provided them with a steady food supply. But living underwater was challenging. People felt isolated and even claustrophobic. The situation came to a head when a group of activists started to protest against the city's expansion plans. They argued that the underwater city was a threat to the environment it was meant to protect, and that the colonists should focus on reducing their impact on the delicate underwater life. The protests sparked a heated debate among the colonists. Some of them argued that the survival of the city depended on its growth and expansion. Others claimed that the city needed to prioritize the protection of the environment above all else. In the end, a compromise was reached. The city would continue to expand, but the main priority would be sustainability and a responsible attitude to nature. The colonists would do their best to reduce their impact on the environment by using new technologies and following strict conservation rules. And they would also remember the importance of protecting the ocean and its fragile ecosystem. Years went by, and the underwater city continued to thrive. New generations of colonists were born, and they grew up in a world entirely different from the one their ancestors had known. They never saw the world on the surface, but appreciated the beauty and complexity of the underwater world they called home. And as the years passed, the city became a symbol of hope for a world struggling with the devastating effects of climate change. It showed that despite all difficulties, people could come together to create a better world. It is a reminder that the future is not set in stone and that we can build it sustainably and in harmony with the natural world.
Do you know what the third brightest object in the night sky is? If you said the International Space Station, you're absolutely right. And the coolest thing? You can sign up for a special service and you'll get a text every time the ISS is traveling over your location. And if it happens at night, you can see it with the unaided eye. But be quick, because the station is very fast. It moves at a speed of 5 miles per second and circles our planet every 90 minutes. If you moved at such a speed, you'd be able to make a round trip to the moon within a day. At the same time, the ISS isn't the fastest human-built object. This title belongs to the Parker Solar Probe that travels around Venus and the Sun at a speed of 430,000 miles per hour. On the bright side, astronauts on the ISS see a sunrise and sunset 16 times every 24 hours. The International Space Station is a true record breaker. It's the largest human-made object in space. It's 357 feet long from end to end, which is about the same length as a soccer field. It also weighs about 450 tons. 8 spacecraft can dock at the ISS at the same time. The working and living space of the station is bigger than a 6-bedroom house. Astronauts have 6 sleeping quarters, a gym, 2 bathrooms, and a beautiful 360-degree view bay window. And now, let's imagine what your life would be like if you were an astronaut on the International Space Station. Now, for one thing, you'd be able to do some cool things there, like throwing boomerangs. Once, an astronaut threw a boomerang inside the International Space Station, and it returned to him. So, just remember, as long as there's some air, even weightlessness won't stop you from having a bit of fun. On the ISS, you would never have to deal with disgusting smells. There's a specially trained person who smells everything astronauts take with them to space. It's done to protect them from unpleasant odors. The thing is that you can't really air the room out there if you don't like how it smells inside. That's why NASA is very careful about what kinds of smells are allowed to pass through. You'd also have to get rid of your clothes instead of washing them after each use. To bring a mere 1 pound of load to the International Space Station costs more than $10,000. That's why it costs less to throw your clothes away when they get dirty than to waste water on washing them. While sleeping, you'd have exceptionally good airflow around you. Otherwise, the carbon dioxide you'd exhale would form a bubble around your head and you'd get oxygen deprived. But what would you do on the ISS? Most likely, it would be space-related research. Astronauts on the station not only explore the possibility of future space travel, but also conduct all kinds of studies and explore the effect of microgravity on the human body. Oh, and speaking of microgravity, people often think that in space you experience zero gravity, hence the weightlessness astronauts feel on the International Space Station. But that's not exactly true. Gravity is one of the most important forces that exist in the universe. Thanks to it, the Moon can orbit the Earth, and the Sun doesn't float away from our home Milky Way galaxy. But astronauts on the ISS experience not full-fledged but microgravity, which means very small gravity. Earth's gravity on the International Space Station is only around 10 to 12% weaker than the gravity on the planet's surface. But astronauts are constantly in free fall. The spacecraft, the people inside, and all the objects aboard keep falling forward, not down, but around our planet, following a specific orbit. And since they're all falling together, the crew and the stuff inside seem to be floating. That's why astronauts can move things as heavy as hundreds of pounds with their fingertips. And even though microgravity is often called zero gravity, they're very different things. Anyway, on your way to the International Space Station, you'd be wearing a bright orange spacesuit. Its color is called International Orange, and it has the same shade as the paint that coats Tokyo Tower in Japan or the Golden Gate Bridge in San Francisco. But once you reach the vast expanse of space, you'd swap orange for Snow White. See, the thing is, the orange suit is equipped with the stuff that can help astronauts survive if something goes wrong during the launch or landing of the spaceship. For example, a regular pumpkin suit has flares, medications, survival gear, a radio, and a parachute. As for the white bulky spacesuits, those are EVA, which stand for extravehicular activity suits. Their purpose is totally different from that of the orange suits. Astronauts put on EVA suits when going on a spacewalk. Such an outfit can protect them from the unfriendly conditions of outer space with its extreme temperatures and the near vacuum. Besides, the white suit can prevent small debris from hurting space travelers. Oh, by the way, if you needed to scratch your nose while wearing your EVA suit, you would use a patch of Velcro inside the helmet. The lack of gravity also makes sneezing inside a spacesuit a serious problem. If you absolutely had to sneeze while on a spacewalk, you'd have to bend your head downward and sneeze into your chest. Otherwise, your visor would have to be equipped with tiny windshield wipers. Now in space, you'd often see random flashes of light, and those wouldn't be hallucinations. Cosmic rays hitting your optic nerve would create such an effect. You don't see similar flashes here on Earth because the magnetosphere doesn't let cosmic rays reach you. Before going to space, you'd have some underwater training. It's supposed to simulate zero gravity, but in fact, it has nothing in common with being in outer space. So the main purpose of this training is to see how future astronauts can deal with extreme environments. Oh, and later, during space adaptation, you might feel, well, let's say, weird. Around 50 to 75% of astronauts have highly unpleasant symptoms, such as vertigo, headaches, nausea, and overall tiredness. Luckily, everything usually gets back to normal within 72 hours. Before you were chosen to fly to space, you'd have to get through incredibly tough competition. According to NASA, they accept only 8 applicants out of 6,000. On top of that, the selection process takes around 18 months. Now, if you felt homesick on a mission and started crying, your tears wouldn't flow down your face. Instead, they'd gather into thick blobs of liquid around your eyes because the water surface tension would hold your tears together. You'd have to remember to attach yourself to something before falling asleep. Otherwise, you can easily float away from the spot where you went to bed and bump into a hard surface. That's why astronauts usually rest in sleeping bags in a small crew cabin. Another issue you'd have to deal with would be taking a shower in microgravity conditions, and it's not an easy feat. Astronauts use a shower in an enclosed cylinder which keeps water from floating away. They use a no-rinse shampoo, spray themselves with water to rinse off the soap, and finally use a vacuum hose that pulls inside all the water left on their body. You'd have to get used to a dramatic change in your diet. You'd have 3 meals a day, nothing outstanding here. But instead of sitting down to enjoy your lunch, you'd float around. Your meal would consist of some dehydrated and canned food items. And it might take a lot of time to finish it, since you'd have to be very careful not to let your food get away in the process. Now, imagine needing a haircut. After all, you'd spend no less than half a year on the ISS. To change your image, you'd have to use special clippers with a vacuum attached to them. You're relaxing in your room and streaming some good tunes when suddenly the network's down. You try rebooting your phone, but there's still no connection. Out of nowhere, your sister barges into your room in panic. She's screaming something about rings. Boxing rings? Wedding rings? Rings on the tub? She's not making any sense. So she drags you out of the house and shows you the sky. You take a look up and see streaks of objects forming miles above the Earth's surface. Her connection seems to work. The two of you check online what's going on, and everywhere the same thing is making headlines. Rings are suddenly appearing in our sky. #EarthRings is breaking the record, and videos are going super viral. Your sister can't help but join the crowd and takes a bunch of selfies with the sky. You run to the TV in your living room to check out the news. Scientists are warning about a coming catastrophe and explaining that everyone should remain indoors. Even though it's a cloudless day in the middle of summer, the weather seems to be getting colder and colder. Suddenly, the signal's cut off. Other channels show nothing either. Then you see your neighbors packing their bags and heading out. Others follow suit. You hesitate a bit, but decide to do the same in the end. Your sister is still outside taking selfies when you urge her to come along with you to seek some answers. The two of you hop in your car and drive out into the city. The rings above seem to be gaining more mass with each second. You and your sister are getting colder and colder. You head to the university to see if anyone knows anything, but there's no one there. Only one parked car in the lot. And it's a good thing you recognize that car. You and your sister rush in and find the astronomy professor doing some quick calculations and trying to figure out why all this is happening. He urges you to take seats and begins explaining. No one knows what this is all about, but it's limiting the sun's exposure on Earth, which explains why it's getting colder by the minute. Why the rings are getting thicker is a mystery too. On Saturn, the rings are made up of ice and rock particles. They can be as small as an ant or the size of a bus. The rocks could be leftover meteor debris or even remnants of dwarf planets. But since Earth is so close to the Sun, ice wouldn't be something you'd find floating above us. With all these rocks piled up, they block the Earth's access to Sun to warm us up and give us light. The professor goes on to explain that Earth will enter a new ice age, and oxygen levels will deplete within a year's time unless those newborn rings disappear anytime soon. This also explains why there's no connection. The rocks that form the rings are hitting and breaking the satellites. Suddenly, you hear a loud ringing noise outside. The three of you head outside and see a helicopter blasting an alarm with a red light flashing.
Everyone to your homes now. This is not a drill. Everyone, head home.
You get in your car with your sister, but the roads are jammed. You have to go on foot, which will take 2 hours. There's no way anyone can remain outdoors. You venture out seeing everyone stuck on the road. They're all arguing with each other and causing chaos. You try not to get caught in the middle of anything and sneak your way to the highway. With the rings getting thicker, less sunlight is breaking through. This Ice Age info is stuck in your head, chilling you even more. You take a deep breath and see a thin mist coming out of your mouth. The sky is getting darker and you're still not home yet. Your sister is tired and needs to rest, but you urge her to move on. You find an abandoned clothes shop and head inside. The store clerks are actually giving away thick jackets for everyone to wear. You grab a couple and slip them on. Only 1 more hour to get home, but the sky is completely dark. There's no way you and your sister can go out in such conditions, so you decide to camp up in the clothes shop. They set up a mini bonfire in the middle of the shop and create makeshift sleeping bags with the rest of the unused clothes. Luckily, there's enough food to feed everyone, including you and your sister. It's the middle of the night. The fire goes out, and you can't see outside the shop. You head to the window and open it up. A huge pile of snow spills in and wakes everyone up. It's the middle of August, and a snowstorm formed overnight. Everyone is freezing, and they start the fire anew. There's no radio or any way to find out what's happening. The wind picks up and starts shaking the shop. Things start falling off the shelves, but you and everyone else are cozy by the fire. The next day, you look outside and see the entire area covered in snow. You live in a sunny place where it barely rains, and the rings in the outer atmosphere are even bigger than last night. Out of nowhere, a truck filled with people pulls over, and the driver tells you there's a shelter for everyone some miles away. The truck has chains all over the tires and is equipped for the worst snowy conditions. Even though it's morning, the sky is pretty dark. You and everyone else hop in. Abandoned cars, some with their doors still open, are scattered all over. The truck drives around them or just smashes through the ones in the way. It pulls over next to an ambulance and takes all the equipment to help the ones in need. You drive past your neighborhood and see your entire house covered in snow. The large tree in your backyard has fallen under the weight of the snow and broken the roof, allowing snow to flood in. The truck speeds through and gets to the shelter, which, to your surprise, is the mall. You get out and see many of the townspeople being led to various stores that have now turned into dorms and health units. You're left in a sports store with a bunch of other people. Your sister has also been able to bunk with you, and to your luck, you see the professor helping out some people. But shortly after that, a loud explosion blasts through the mall and shatters glass screens. Everyone ducks for cover. You see people running outside. You head out and see a large metallic object lying in front of the mall entrance. There are people crowding the entire area, so it's not easy to see what all the fuss is about. But after getting a closer look, you find out it's a satellite fallen from orbit. It crashed in the front yard and made the boom. There were also reports of other satellites crashing on Earth in the most random places. That means all communication has been wiped out of the map. You run back inside the mall to await what happens next. You look at your sister in fear, not knowing that the new Ice Age has just begun. One year later, you're relaxing in your bunker when your sister barges in, freaking out. The rings are still there, but it's something else now. You run outside and see everyone gathering around and looking at the sky. Within a year, temperatures have dropped to freeze the entirety of the Earth's surface. Deserts and tropical jungles have turned into icy wastelands. More than half of the wildlife went extinct, and trees are as rare as a four-leaf clover, which means oxygen levels have dropped significantly. Most of the population, or what's remaining of it, live with oxygen tanks, with scientists still trying to crack the case of the rings. Exactly what the professor predicted. But up in the sky, rocks seem to be falling down and crashing all over. It starts off far away, but then the rocks begin to fall down close by. You and everyone else run back into the mall, which has been covered with a layer of metal to keep the warmth inside. It should be pretty safe in there. If the rocks are falling down, that means the rings are dissipating. Suddenly, you're full of hope that the Ice Age might be over soon.
There's only one star in our solar system, the Sun. And all the planets orbit this star. But there are also systems where a planet orbits two suns. For example, Kepler 16b. It's an inhospitable and cold place, made of half rock, half gas. But the coolest thing there is that if you visited this planet, you'd see two sunsets and have two shadows. But astronomers seem to have found something rarer and more bizarre. There might be a planet that orbits three stars at once. The GW Orionis star system is around 1,300 light-years away from our planet. It's composed of three orange rings. They're made of dust and nested inside one another. In the center of this system, you can see three stars. Two of these stars are binary. It means they orbit each other. The third star revolves around them. Scientists have found out that the three rings are misaligned. The innermost ring swings widely in its orbit, and the outermost ring has a tilt of 38 degrees. So, astronomers came up with two theories. The first theory says the break in these rings occurred because three suns created torque at the center of the entire system. Torque is a gravitational force that always acts toward the center. But sometime later, this theory was written off. There wasn't enough turbulence in these rings for this theory to work. The second theory claimed that this phenomenon could be happening because a planet formed inside one of these rings. A young planet could affect the gravitational balance of the three-ring system and be the reason they were spread so far apart. There's a specific gap in the dust cloud. Based on its size, the planet we're talking about must be a large gas giant the size of our Jupiter. All space objects have been formed thanks to gravity pulling matter together. If there's even the slightest rotation at the beginning, the spin rate increases with time, especially when an object starts collapsing. That's why all space objects rotate, including dust particles and even black holes. Black holes lose their mass because of a thing called Hawking radiation. Their event horizons are becoming smaller, but this process is very, very slow. A black hole's event horizon is a point of no return. It's like a boundary that surrounds a black hole, and nothing, including light and radiation, can escape once it crosses this boundary. The average black hole would need billions of times the age of our universe to disappear completely. Our home Milky Way galaxy might also contain a supermassive black hole, but we're in no danger. One of the closest large black holes, V4647 Sagittarii, is most likely 20,000 light-years away. It's safe to observe the effects black holes create from a distance. Problems start when you get too close because of their mind-boggling gravitational force. Galaxies can consume one another, which is one of the ways how they evolve over time. Our closest neighbor is called Andromeda, and it's currently munching on one of its satellite galaxies. In the past, Andromeda ate at least two others. Plenty of star clusters are scattered all over this galaxy. Andromeda must have stolen these stars from other galaxies. Scientists have finally managed to identify those stars. They have tracked them back to galaxy mergers that happened billions of years ago. 10 billion years ago, our home galaxy also went through a collision. That's why now its halo isn't like the ones other spiral galaxies have. Scientists first thought it was several small collisions, but then they realized that most of these space objects in the Milky Way came from a single source. It was another galaxy, Enceladus, that the Milky Way collided with. The Milky Way and Andromeda galaxy might collide, but it's unlikely to happen in the next 4.5 billion years. Neutrinos are electrically neutral particles that are so powerful that they can go through miles and miles of lead, and nothing will stop them. Some of them are passing through your body as you're watching this. Neutrinos get formed both in the nuclear reactions inside alive stars and in the supernova explosions when stars go out. These particles are nearly massless. They need less than 3 seconds to get to the surface of the sun, and then they can reach our planet in only 8 minutes. There's a planet, TOI 1231b, around 90 light-years away from Earth. It's similar to our Neptune. It's a gas giant, but the most interesting thing is that this planet is likely to be rich in atmosphere. The planet is over 3.5 times as large as Earth and a bit warmer than we're used to, 134 degrees Fahrenheit. It orbits a red dwarf star, way smaller than our sun. But this star is also much older. 1 year on the planet is only 24 Earth days long. Even though the planet is close to its parent star, it remains relatively cold. That's because its star is on the cooler side too. Astronomers think they've seen clouds in the atmosphere of this mysterious planet, and maybe they're even made of water. This star and planet system is moving away from Earth pretty fast. That's why scientists easily detected hydrogen atoms that were escaping from the planet's atmosphere. Yep, that means the planet may even have a tail. A hypothetical white hole is a bizarre space object that is the opposite of a black hole. It's intensely bright and was first mentioned by Einstein in his theory of gravity. Most often, scientists talk about white holes in the context of wormholes. There's a theory that a black hole is like some sort of entry point to a tunnel that takes you through space and time. In this case, a white hole might be an exit located somewhere else in the universe. On the other hand, white holes don't necessarily need to be exits from wormholes. They could also be a slow-motion replay of how original black holes were formed. So, the formation of a black hole starts with an old massive star. After it collapses under its own weight, it usually turns into a black hole. But sometimes, quantum processes don't turn a star into a black hole. Instead, they make a white hole that starts spewing out the matter of the original star again. But so far, this is just a theory. Some planets, like Mars and Venus, have pretty intense weather with powerful storms. And now, an equally strong space hurricane might have come to Earth. It was a swirling mass of air about 620 miles wide. Satellites spotted the hurricane hundreds of miles above the North Pole, somewhere in the Earth's upper atmosphere. The hurricane was raining not water, but electrons. It lasted almost 8 hours before it finally broke down. It was spinning in a counterclockwise direction. It's possible there are oceans hidden under the surface of the moons surrounding Uranus. Scientists have also been investigating the oceans on Jupiter's moon Europa and Saturn's moon Enceladus. These oceans are hidden below the moon's icy crusts. Uranus has 27 moons. 5 of them are especially big. Those are Umbriel, Titania, Oberon, Miranda, and Ariel. Back in the 1980s, when people sent Voyager 2 to get us some images of these 5 moons, scientists found out that they had lots of craters and were made up of ice and rock. Pictures astronomers got then also showed signs of liquid water. It was erupting from the moon's depths and freezing on the surface. One of the most plausible explanations was the oceans under the surface. As a moon moves around a planet, the magnetic field of that planet tugs at it. That is how the moon stays in its orbit. This tug generates an electrical current that transforms into a magnetic field. Such a magnetic field is called induced, and subsurface oceans might be the reason why this induced field can be produced. Saturn is well known for its famous rings, but Neptune, Uranus, and Jupiter also have rings. At the same time, Saturn has something really special we've never seen on any other planet. It's this huge hexagon storm moving around the planet's north pole. Each of its sides is almost 7,500 miles long. That's an area so great, we could place almost 4 Earths inside. According to thermal images, this hexagonal cloud pattern goes down into Saturn's atmosphere for around 60 miles. The planet is hiding behind thick clouds, and sunlight can't get through them. That's why astronomers can't see what exactly is going on there. But there are theories. Saturn is a gas giant. When gas deep inside the planet gets heated, it strays further out. Huge amounts of energy are released along with that gas, which makes it rise, expand, and lose density. The same processes cause hurricanes and tornadoes on our planet. On Saturn, whirling gases come out of a high-pressure zone located within Saturn's outer layers, and these gases trigger a powerful storm of such an unusual shape.
This planet's called the jewel of the solar system. Made up mostly of gases, it could float on water should you find a reservoir 75,000 miles across and just as deep. But what makes the planet so recognizable is its beautiful rings, gray, tan, and beige. They consist of dust, rocks, and ice. Some bits are as tiny as grains of sand, others as large as skyscrapers. The planet I'm talking about is Saturn, and right now, Earth is hurtling toward it at breakneck speed. It all started on a regular day over half a year ago. All of a sudden, Earth changed the course it had been following for several billion years. But instead of rushing toward the Sun, it started to move away from the star. On second thoughts, it might be for the better. We've got more time to find a solution. Earth used to move around the Sun at a speed of 67,000 miles per hour. For some mysterious reason, when it left its orbit, the speed remained the same. It means we're going to cover 746 million miles, separating our planet from Saturn within a year and 3 months. At first, no one realized what had happened, but a couple of hours later it became obvious. Despite the panic that engulfed Earth's inhabitants, nothing seemed to be out of the ordinary. But all too soon, it started to get colder and colder. Astronomers' forecasts were pessimistic. People started to leave their homes at the poles, move closer to the equator. Most plant and animal species were having a hard time. Some of them went extinct, even though we were trying to save them in greenhouses and special conservation parks. The sky changed dramatically. In a week, we could see Mars clearly. It looked like a big reddish sphere hanging low over our heads. Jupiter became as bright as the moon. Once Earth was as far away from the Sun as Mars, days became twice dimmer than they used to be. At first, our planet's atmosphere was acting as a barrier between people and space. That's why we didn't feel the cold immediately. But 7 days later, everyone who dared to leave their home had to be cocooned in heavy winter clothing. By that time, the temperatures had already dropped down to minus 145 degrees Fahrenheit. It got even colder once our planet passed Mars and hurried through the asteroid belt. It's been one of the most dangerous regions on our way so far. Yes, people could admire awesome meteorite showers streaking the sky. But several space bodies managed to get through the Earth's atmosphere. They slammed into the ground, flattening mountains and leaving behind gigantic craters. They caused tsunamis and triggered earthquakes. Right now, most of the planet, including the oceans, has already turned into an icy desert. There's a lack of food and natural resources. We've built underground towns and tunnels connecting them. Our scientists work day and night to find a way out of this situation. If they don't, that's what's going to happen. The closer our planet will be to Saturn, the more the ring planet will loom over the horizon and the larger it'll look. Soon, it'll already shine brighter than the full moon. The massive yellowish-brown orb will be visible even during the day, but it'll look especially impressive at night. Instead of sleeping, millions of people will spend hours watching Saturn grow larger and larger. One day, the distance between the two planets will become the same as the distance between Earth and Mars used to be. Saturn's disk will be about a quarter the size of the full moon. Its rings will be as large as 2/3 of our natural satellite. Soon after that, our planet's speed will start to increase under the influence of Saturn's gravitational pull. The ringed planet is 9 times wider than Earth, and its mass is almost 100 times greater. That's why, instead of moving at a speed of 29 miles per second, we'll be dashing through space at almost 40 miles per second. That's 2,400 times the average car speed. Saturn's gravity will influence the Moon more than that of Earth. In no time, we'll lose our satellite. It'll get catapulted into outer space, likely to go into an elliptical orbit around the Sun. If Earth wasn't about to crash into Saturn in the nearest future, the Moon could one day cross paths with our planet again. No good would come out of such an encounter. But what's happening on Saturn's side of things? Saturn is one of the largest planets in the solar system, second only to Jupiter. Even though the rings surrounding the planet are huge, they're rather thin, less than a mile thick. Still, the main rings are large enough to stretch from Earth to the Moon. But how did the planet get these breathtaking accessories? Beyond the outer edge of the main rings, A, B, and C, there's something astronomers call the F ring. Several million years old, it's the weirdest one. This constantly shifting ring is made up of icy material and is incredibly complex. Its curves, twists, and clumps of brighter substance make it look as if it's braided. Saturn has more than 50 confirmed moons. 2 of them, Pandora and Prometheus, flank the F-ring on either side. They weave outside and inside the ring, acting like shepherds. They herd ice particles into a 60-mile-thick band. But why are they performing this elaborate dance? No one knows. What scientists do know is that when Saturn's rings were evolving, icy material clumped together and formed moonlets. Some of them grew and turned into the planet's largest moons. But 2 of them collided. That's how the mysterious ring F appeared. If the moonlets had only been made up of small icy particles, the space collision would have left a ring and nothing else. But they had dense rocky cores. Those remained intact and turned into Pandora and Prometheus. People don't have any evidence Saturn's ever collided with another space body. Our Earth might be the first. But before crashing into the planet itself, we'll have to get through its rings, including the ring F. And no, our planet won't just punch a hole in them. Saturn's rings are made of small particles. Earth's gravity will start to pull some of them out of their orbit once we're close enough. It'll result in a long plume that will reach our planet. And later, when we squeeze through, the cloud of icy particles will drag after Earth. It won't have enough power to rid Saturn of its rings completely, though. They'll continue to move around their home planet, but their orbits will change and become more elongated. There will be no more stunning bands. Over time, the rings could probably settle down again, but Earth won't give them such a chance. The collision with our planet won't leave Saturn unscathed. If there's still a possibility to sneak a peek at the sky, people will be able to see the rings disappear into nothingness, but not for long. Soon, the largest chunks of rock will start hitting the surface of our planet, leaving behind lifeless land dotted with craters. In the worst-case scenario, Earth might even collide with one of Saturn's numerous moons. But let's imagine we've passed through this region in one piece, and now our planet's very close to Saturn. The gas giant might seem airy, but there's no way Earth can fly through the huge sphere and leave from the other side. Gravity is what keeps all that gas together. The very gravity that make our planet speed up. The closer it is to the much bigger space body, the stronger the pull is. It'll cause the fault lines on Earth to rupture. It'll also set off powerful volcanic eruptions all over the world. And then, with enormous force, our planet will crash into Saturn. The planet's atmospheres will get compressed. This will cause a dramatic and fast temperature rise, and in no time, the air will be on fire. Scientists claim that Saturn's core is dense, made up of iron and nickel, and surrounded by a rocky layer. But we'll never make it there. Earth will burn in the bigger planet's atmosphere after being literally torn apart. Our beautiful, blue-green world will turn into billions of trillions of tons of vaporized rock. Pity. Maybe Earth will become yet another Saturn's ring, instead of the ones it's ruined. Sounds grim, I know. Yeah, we can't save Earth from Saturn, but that's only a bad dream. So maybe we take that effort and save us from a real threat, climate change. Just saying. Two bright beams of sunlight are traveling across your forehead, cheeks, eyes. Ooh, you scrunch up your face and sneeze loudly. It would be nothing unusual if the sun's rays weren't coming from two different stars. Yup, you're still on Earth, but this Earth has two suns. What would your life look like in such a world? It'd depend on the star's mass and their positions relative to Earth and each other. If the stars were small, their gravity wouldn't be enough to keep our planet in its orbit. It'd eventually drift away into space. But if one of the stars was larger than the other, it would have a much stronger gravitational pull, and sooner or later, Earth would end up too close to it. It'd become too hot to live on the planet. You know, boiling oceans, evaporating rivers and glaciers, and scorching hot air. Lovely. In the end, our once blue world would crash into the star and, disappear. The only chance for Earth to have a stable orbit would be to move around only one of the two suns. But it wouldn't be that great for all kinds of life forms on the planet. Every once in a while, the two stars would face both sides of Earth. It would mean there would be no nights. Our planet would get twice as much heat as usual. It'd also be bombarded with double doses of radiation. And of course, solar winds would become twice stronger. During such periods, you'd have to hide indoors and probably order drone delivery. Because you set your foot outside, the two suns would get you toasted in no time, what with all that heat and solar radiation. Uh-oh, it doesn't sound optimistic. Maybe it would be better if our planet was moving around both stars. Perhaps. Its orbit would be rather unstable in this case, and still, it would be better than experiencing crazy heat waves every now and then. But in this situation, the stars would have to be close to each other, and Earth would most likely travel too far away to get enough heat to keep its water liquid. If our planet had been developing in such conditions from the very beginning, now it would be just a frozen rock with no life on it. How about the most optimistic scenario? Our planet would get itself two similar-sized stars, and each of them would be more than half as powerful and bright as our current sun. By the way, it sounds rather realistic. Such equal-mass double stars do exist. Their common gravitational pull would be just enough for Earth to not fly out into space, and the amount of energy our planet would get would be more or less the same as it receives now. But the combined mass of the stars would be about 1.5 times the mass of our current sun. It would mean their gravity would also be stronger, and 1 year on the planet would be shorter. It'd last not 365, but around 280 days. But Earth would only feel comfortable if it was at least 4 times farther from its stars than they were from each other. Then our planet would happily move around their common center of mass. In other words, the suns would have to be less than 10 million miles apart. Then the rest of the planets in the solar system, including Mercury, would have stable orbits. If you lived on the Earth that was moving around two stars, you'd be able to watch awesome solar eclipses. But it would not be the moon blocking the sun, but one of the stars preventing you from seeing the other. Instead of several minutes, eclipses would last for hours on end. They would also occur much more often, maybe once in a week or so. If the stars were a bit larger in size, there would be 2 types of eclipses. Every now and then, a smaller star would block the larger one, but only partially. But when the bigger star blocked the smaller, it would result in a total solar eclipse, complete darkness. 2 suns would mean days would become brighter. Nights, sunrises, sunsets, these would change too. The star would set and rise at different times. So, arriving too late to watch the sunset? It wouldn't be a problem. You'd still be in time for the second one. With 2 suns, the seasons on Earth might also start to change more rapidly. They would be harsher than now. Most life forms on the planet would be struggling to keep up with intense and fast climate changes. But returning to the combined gravity that would be stronger than what we have now. Because of this, everything on the planet's surface would look different. Trees would be thick and short, plants stiff and tough. Animals would be way bigger and sturdier. Their legs would be more massive to support their weight. It would increase due to the stronger gravity. People would most likely be bulky and short. Their bones would be thicker, either to withstand higher gravity or because of constant breaking and healing. Humans would also have stronger muscles, lungs, and hearts. Well, at least the gravity wouldn't double at once. If it happened, our planet's core would probably collapse on itself right away. Then it would release so much heat it would burn everything on the surface, like us. Even if the gravity was increasing gradually, adapting to this new world would still be a challenge. Buildings and bridges would collapse under their new weight. Planes wouldn't be able to fly. In any case, discussing what Earth would look like with two suns is nothing but a guessing game at the moment. But scientists know for sure that such planets do exist. Kepler 16b was discovered by the Kepler Space Telescope. The planet, the only one astronomers know about so far, orbits two stars. It has beautiful double sunsets and is around 200 light-years away from Earth. But this planet isn't a welcoming one. It's the size of Saturn and extremely cold. Kepler 16b is mostly made of gas. It might have a rocky core, but astronomers aren't so sure about that. The planet is also out of its star's habitable zone. That's the area where there might be liquid water. Plus, the stars are colder than our Sun and much smaller. One of them is less than 70% of our Sun's mass, and the other just 20%. That's why scientists are almost sure no life could survive in such a place. It's highly unlikely Earth could be developing in the same way, even if it was orbiting two stars. After all, our planet isn't a gas giant like Kepler 16b. But if this had somehow happened, Earth's fate would be very different now. The temperatures on the planet's surface would be lower than minus 100 degrees Fahrenheit. All water would be frozen, and the chances are Earth would never have turned into the blooming green paradise we live in. At the same time, our Sun might have had a companion long ago. It could be Nemesis, a theoretical dwarf star. If it had been a white dwarf, just a teaspoon of its matter would have weighed more than 5 tons. It's almost as heavy as an elephant. White dwarfs are extremely dense. They can be the size of our planet, but as massive as our Sun. Such a dwarf star could be responsible for several mass extinctions on Earth. Scientists think it could somehow affect objects in the outer solar system. It's the region which is home to giant planets, Jupiter, Saturn, Uranus, and Neptune, and their moons. Anyway, Nemesis could push different space bodies off their course. Then it probably hurtled them toward Earth, where they collided with our planet and caused terrible disasters. It's just a theory, though. Many scientists don't support it, and astronomers haven't found any evidence yet. But a 2017 study suggested such a star could exist in the ancient past. Even better, the researchers claimed each star, like our Sun, was once born with a companion. But even if Nemesis had existed all those billions of years ago, it would have broken free of the Sun's gravity quite early in its history, and then it would have wandered off into the Milky Way.
Have you ever wondered what it would be like if every planet in our solar system was the size of Earth? Well, it's time to dive into this mind-boggling scenario. Let's imagine what each planet would look like if they were as big as our beloved blue planet. Would the barren red landscape of Mars suddenly become a lush green oasis? Would the massive swirling gas giant Jupiter just disappear? And how would it affect our solar system as a whole? Are we all doomed? Buckle up and let's find out. The first planet on our list is Mercury, the smallest planet in our solar system. But now, forget about the moon-like Mercury. Instead, picture yourself on the surface of a super dynamic incandescent inferno. There are a lot of craters and active volcanoes around you, and right in front of you is a huge, blinding bright sun. What a nightmare! But let's break these changes down. Well, along with the size of Mercury, both its mass and gravity would increase. In that case, it's possible that Mercury would have more atmosphere. Temperatures on Mercury are extreme, not only because it's very close to the Sun, but also because of its very thin atmosphere. So during the day, the temperatures there reach 800 degrees Fahrenheit. And at night, it becomes terrifyingly cold. down to negative 290 degrees Fahrenheit. But now, when the gravity is stronger, Mercury could have a denser atmosphere, so the heat would be better distributed across the planet. And the atmosphere isn't the only thing that could make it hotter. If Mercury became bigger, it would likely experience increased internal heating due to gravitational compression. And hypothetically, its tectonic activity could increase. In other words, more interesting landscape, more mountains, and more scary active volcanoes. Congratulations, you've turned Mercury into Venus 2.0. For us, all these changes wouldn't be very pleasant. Now it would become much harder to send our spacecraft there, so it's better for Mercury to stay as it is, small, calm, and boring. Basically, the complete opposite of our next planet, Venus. So what would happen to Venus if it was Earth-sized? Actually, nothing. It wouldn't change at all because Venus is already almost the size of Earth. It's even called the Earth's twin, although twin is a big word, of course. In reality, we couldn't be more different. Venus is often called the morning star because it's so bright and visible in the sky. But don't let its beauty fool you. This planet is one of the most inhospitable places in our solar system. Its surface is hotter than a freshly baked pizza, around 900 degrees Fahrenheit, and it's covered in thick clouds of sulfuric acid that would dissolve any human who tried to visit. So, unfortunately, you won't be planning any trips there anytime soon. So let's move on to a planet that, unlike Venus, could potentially become a new home for us, Mars. Picture yourself standing on Mars's surface, watching the blue sunset and breathing in a refreshing breeze of air. Yes, you read that right, air. Moreover, you could be surrounded by plants, animals, and basically feel like you're on Earth. But how is that possible? Bigger Mars would have a stronger magnetic field and gravity. This would lead to a richer and denser atmosphere. It would likely have a wider range of gases, including oxygen. Wouldn't that be cool? Also, a denser atmosphere could distribute heat across the planet, so Mars would become much warmer and cozier. And here comes the most important change: liquid water. Mars actually has some frozen water at its poles and in subsurface reservoirs. But with a stronger gravitational pull, it could potentially stabilize liquid water on its surface. Hooray! However, it's not all fun and games. New Mars would also have a volcanic personality. It's already geologically active, but now its internal heat and pressure would skyrocket. That means more frequent and more crazy volcanic eruptions. Imagine how exciting it would be to witness such eruptions on another planet, if you manage to escape the consequences. In general, the planet could become greener and lusher, but not safer, although it would still be great to see it. But it's time to move on to the giants of our solar system. And if we're enlarging the planets before, now it's time to squeeze them really, really hard. If Jupiter became 11 times smaller, oh boy, what a disaster that would be. The first thing we'd notice is a change in gravity. And I say we'd notice because now we'd have no choice but to move somewhere. Jupiter experiences from 30 to 100 collisions with large asteroids per year. No big deal, all because of its strongest gravity, which attracts them all and protects us. But now our big protective brother has turned into a small baby. Say hi to a bunch of asteroids. Oh, and say bye-bye to Jupiter. This planet is known for its thick, swirling atmosphere. But with a weaker gravitational pull, Jupiter would probably have a hard time holding on to it. So over time, it would slowly escape into space, leaving behind a thin atmosphere composed mainly of nitrogen and oxygen. We'll also have to bid farewell to the iconic appearance of another giant, Saturn. The most noticeable difference would be the disappearance of its famous rings. Made up of small particles of ice and rock, the rings are a unique feature of Saturn. But with Earth's gravity, they would either fall onto the planet or scatter into space. Bummer. Saturn is also a gas giant, just like Jupiter. Its atmosphere is made up of mostly hydrogen and helium. But if it were Earth-sized, its gases would be compressed due to the increased gravity. This would make it much denser. That means Saturn's overall size and shape would change. Theoretically, if we squeeze Saturn hard, it could potentially become a brown dwarf. It's a type of failed star that lacks the mass to sustain nuclear fusion, but emits heat and light. So, Saturn could stop being a planet altogether. The weather on it would probably have changed too. All its crazy storms, such as the famous hexagonal storm at its North Pole, would have become weaker and calmer. The next giant is Uranus. Let's try to compress this poor fella. First off, the surface gravity on Uranus would be much weaker than it is now. Its atmosphere might also change. If Uranus was smaller, it could have a thinner atmosphere and different gases altogether. This planet is pretty chilly, with an average temperature of -353 degrees Fahrenheit. Ugh. But if it was the size of Earth, it might actually warm up a bit due to its reduced volume to surface area ratio. Don't get too excited though, it would still be way colder than the coldest spots on Earth. As you can see, gas giants don't easily go through all this shrinking, except perhaps one of them. Surprisingly, small Neptune would become much friendlier. For starters, it would probably be a rocky planet with a tiny atmosphere. That means no more gas giant, but instead, a planet that's easier for humans and critters alike to live and move around on. Speaking of movement, because of the smaller size, the gravity on this new Neptune would be almost the same as Earth's, making it a heck of a lot easier to walk and jump around. No more floating away into space. Now, the atmosphere of the original Neptune is so thick you could barely see your hand in front of your face. And the surface pressure is about 100 times that of Earth's atmosphere. But our new Neptune would be much different, with a much thinner and less dense atmosphere. It would still have some methane, water, and ammonia in it, but nowhere near as much as before. Finally, the temperature. The current Neptune is freezing, with an average temperature of about -370 degrees Fahrenheit. But if it was the same size as Earth, it would likely be much warmer, just like Uranus. Ah, that's more like it. What a planet that would be. That's it for the changes in the planets. But what would happen to the entire solar system if we made all the planets so small? It's hard to predict, but it's clear that their gravity and orbits could change a lot. It's unlikely that any of them would have flown into outer space, or crashed into each other, or something like that. But many of their orbits would probably become quite unstable, and the number of collisions with asteroids would have increased significantly. Of course, all this is purely speculation. It's not like we can actually test all this. But it's still a pretty interesting thought experiment, and it makes you